All right, so hello everyone. I'm Nicholas Gardella. I'm a systems engineering PhD student here at UVA. I did my undergrad in computer science at Virginia Tech, and I'm in the chapter here of Human Factors in Ergonomics Society, and we're hosting this website workshop as a way to help people learn how to do a DIY web presence for themselves using the kind of tools that technical computer science people are using, but for people who maybe have not used these technical scary tools like the command line, like Docker, like Node, like GitHub. If you've never used this kind of stuff, this may be like drinking through the fire hose, but hopefully it will be fun and you will learn something along the way. So if you're following along and something is confusing or we're moving too quickly, be sure to like use a reaction in the chat or say something in the chat or even unmute yourself and talk, because I want this to be something where you can follow along, and hopefully if you have everything working right, you can publish a website for yourself on the internet by the end of the workshop today. So I'm going to get started. And there's a website actually that I made with this technique that we're going to be using for the purposes of the workshop. So if you want to go to this website on your own computer so you can follow along there, it is learn.hfes.@uva, all one word, .ga. If you go to that web address, you'll find this resources site. We plan to have other resources up here in the future, other things for the HFES chapter at UVA, for example, finding internships related to human factors for those of us who are interested in that kind of thing. But also we'll hopefully have videos from workshops like this and text resources. So if you go to the Build a Website tab or the Build a Website section on the left, you should find everything you need. It might be a little challenging to follow this guide without having the help of the workshop live, but technically you could do it all from this text. So if you can't do it right now for some reason, or you only have one computer with you and you want to do it later, you can go to this site and try your best to follow the instructions. And if you do have any questions after and you're really interested in doing this, you can contact me or the HFES email and it can get to me, so that we can answer your questions. So things will be a little bit different depending on whether you have a Windows computer or a Mac or Linux computer. That's pretty common with coding stuff. I tried to make this as standard as possible so that everyone can use similar files, similar commands, and all that stuff. But first of all, I just want to talk a little bit about how websites work, how the internet works, so that you can get a sense of how things are going to be working under the hood. So when you go to a website like google.com, you've just entered a domain name, www.google.com, and you're just asking the universe for whatever google.com is. And so you know that when you ask for google.com in your web browser, it's going to bring you the search engine that you're used to. So you could do that for all the sites, you know, Instagram.com, Facebook.com, and you may be used to seeing things like this www dot, or you may even see something like www dot and then docs.google.com, and I don't know, that's doc, but docs.google.com, and that might bring you to Google Docs, or drive.google.com might be Google Drive. So you can access different things on the internet in sort of a hierarchy. And so if you look at this URL, hopefully you can see that on the screen share, the top level domain is what this end part, the com, is called. You might know other ones like org, net, edu. The one we have for this site is GA. I'll talk about why that is in a little bit. But that's a top level domain. So essentially, your computer is going out into a special place on the internet, which we'll talk about, and it's saying, of all the com domains, give me Google. And Google has registered itself as Google. So you'll go to Google, and then Under Google, you'll say, from Google, I want the docs subdomain. And so it's going to give you docs.google.com. So it's sort of a hierarchy, and you can go arbitrary levels deep. And that's why we can have this URL for the site, which is learn.hfes.uva.ga. So this is the most specific thing is we're learning, we're getting resources at the HFES organization, which is under the @UVA domain, which is under the top level domain GA. Does that make sense to everybody? So the way that you might be wondering, how does the internet know that google.com should go to wherever Google is, and what is even happening there when that happens? So to understand that, you do have to understand a little bit about how the internet works. And for those of you who don't know much about how the internet works, this may be overwhelming, but bear with me. So you can go to the publishing Freenom DNS section if you want to follow along with what I'm talking about here. And there's information you can read here. But basically, the way that the internet works is we call each other with these phone numbers that are called IP addresses. You may have heard IP address refers to internet protocol, and it's essentially just a phone number for the internet. And so you might have seen an IP address like google.com's IP address, which I have here. So this is the one that you can find online for an alias of google.com. I'll explain what that means. So you're like, what? You can just put a number in the URL bar? Yeah, you can. So magically it went to google.com. So the reason for that is that what google.com has registered in the DNS domain name system, DNS, is this IP address. And they may change that in the future. They may use multiple, but this is one that currently, as of May 16, 2022, you can access google.com. So we're essentially doing a lookup where our browser knows that we want to look at web documents. We want to look at things we can read. So we're going to use a certain protocol that's standard for the web. You might have seen that as being HTTP:// or HTTPS. The S just is a secure version of the regular one. And basically what that means is anytime you're using a browser, by default, you're using the HTTP, the Hypertext Transfer Protocol. Just means that you're getting special linked up documents, and you're doing that over the internet. So by default, when you go to, I can just type nothing else but google.com, and that works. But all I've specified is the apex domain, Google, and the top level domain, com. So what's actually happening there? Well, there's a lot of assumptions being made because you're using a browser. There's lots of other ways that you can use IP addresses and that you can use domains. And so an equivalent to google.com is actually this much longer address, https://www.google.com:443. And you probably, unless you're, have done coding before, you probably never entered a URL like that. But I swear it goes to google.com. And the reason for that is that this is just a very specific way of using the internet that we do in browsers. And there's lots of other ways, but this is just the one that we do. So when you put google.com, it assumes you want to do HTTP or HTTPS. And then Google kind of picks its favorite, which tends to be the secure one. And then it automatically knows you want to do the www subdomain, which is really nothing special. That's just the same as learn.hfes. It's just www. You might have gone to a weird website before where you see www.website.com. And that's also something that people do when they want to have multiple subdomains, and then they can kind of swap things around and move things in and out. So we've explained the HTTPS and the : // that's just, we want to use this protocol to talk to www.google.com. And then what's this : number at the end? That's just, it's something called a port number. And a port is exactly what it sounds like. It's just essentially a virtual hole that you can plug in a wire to, a virtual wire. So you have google.com has lots of virtual places where people can plug things in so that they can talk about different things. In this particular way, we want to talk about web documents. We want to talk about text because Google wants to give us the search engine. So it's using the protocol number 443, which is the one that is standard. People use this everywhere for HTTPS. And if you've used an insecure website, an HTTP website, and you've seen that little security warning that your browser gives you maybe, that's probably working on port 80, which is the standard for HTTP. So really when you put in google.com, all this other stuff is kind of implied. So hopefully that wasn't too confusing. I know that's a lot of information, but the big idea here is that we probably, if you've made a website on something like Squarespace or Weebly or Wix, you might have a site that actually utilizes a subdomain. You might have like, you know, nicholas.weebly.com, like that. Maybe Nicholas is my subdomain that Weebly gave me on their Apex domain. So they've reserved that special subdomain just for me. But the reason that I always have to have that .weebly.com is because it's not my Apex domain. I don't own Weebly.com. They serve lots of things there. So my Nicholas subdomain is just one of the many subdomains, and maybe Nora will have Nora.weebly.com, and Lauren will have Lauren.weebly.com, and somebody else, and maybe Nora has a document service that she wants to call docs.nora.weebly.com. So hopefully this is starting to make a little bit of sense, but I personally don't really like this. I don't want Weebly in my website URL. It looks unprofessional. I mean, it also looks a little unprofessional to have a top-level domain like GA because you're used to something like .com or .net or .edu. But that's just sort of a symptom of wanting to do something for free, and we'll get to that. But basically, I prefer to have, over having nicholas.weebly.com, I would much rather have nicholas.ga. So I get to manage that whole domain, nicholas.ga. If I can, I'd much rather do that than have to share an Apex domain with lots of other people. So that's essentially what we're trying to do with the DNS. We can get a subdomain pretty easily with the tool we're going to use to publish the website, but I want us to get a better domain that we want to put on our resume. So the next part of this is what's actually happening when you call nicholas.ga. So we talked about how that's being translated into an IP address. And there's lots of servers, just computers out in the world. There's this meme I like. It's like the cloud is just somebody else's computer. I don't know if you've seen this. It's the joke of cloud engineers, but there is no cloud. It's just somebody else's computer. So basically, what that means is this ambiguous thing people talk about of, oh, I'm going to put it in the cloud, or when you put something on Google Docs, you're not really just shooting it into the sky. You're actually putting it somewhere. So what you're doing is you're calling somebody else's computer using an IP address or DNS name, and you're just saying, here, I want to give you some stuff, hold on to it for me, and you come back later and you get it. That's basically what's going on there. So they're providing you a service. And we talked about how when you put google.com, that's actually going to their IP address, which was that number that looked like this, 142.250.81206. So really what's happening is you're saying google.com, and then there are these servers out in the abyss where you're connected to by default. It's a little confusing. You probably didn't know that this was true, but when you're connected to the internet anywhere, you're by default using some kind of DNS settings, which just means when I want to look up people's IP addresses. So wow, that looks really bad on there, doesn't it? Okay, so when you want to look up IP addresses, so you can think of this like you want to call your friend, you have to look up, maybe you should know your friend's phone number, but you want to call like a business. So you look up their phone number in the phone book, and then you open that page, you find their number, and then you call their number. But the information that you start with is just who you want to call, right? I just want to call google.com, but I don't know their number yet. So you have these default domain name service IP addresses. So those are also addresses of people that you're going to go call. So these are just the default places that your computer is going to say, when I want to ask who google.com is, here's who I'm going to go ask. That's all that is. And I could tell you about how your privacy is sacrificed by the current DNS settings you have right now. But I'll save that because there's a lot to get through. Basically, on my computer, I'm using these DNS servers. So whenever I want to get an IP address for somebody, I call 1.1.1.1. And then they tell me google.com means this IP address, and then I call them. Okay, so now I've gotten to the point where I've actually called somebody else's computer. And so what's happening when I call somebody else's computer is that they have obviously written some code, right? This is fancy. Stuff happens when I click on things. I can search, there's a microphone, all this good animation and things. So what's happening here is that Google built an app and they compiled that app and they turned it into, they basically took code and they turned it into a fancy document. And then they bundled up that fancy document and they sent it to me over the internet. And now I have it. And I could actually turn my Wi-Fi off. I'm not going to do that because then I would get kicked out of the meeting. But I could turn my Wi-Fi off and things on this page would actually still work. I could, click here and I would still get these drop downs from whatever had been loaded because Google sent me a bunch of stuff. And then when I perform actions on here, like I type something in and I hit search, now I'm going to trigger more web traffic. I'm going to go and have to ask for new stuff because obviously they didn't know what I was going to put in. But the very basic part of it is that you're calling the website and you're just basically asking to get it, and you have custody of it once you ask for it. So I asked Google for google.com, they gave it to me, and now I have it. It's physically on my computer. It's in my browser, and the code that they wrote is actually running inside my browser. My browser runs code. I don't know if you knew that. It's pretty crazy. So when we go to this learn.hfes.uva.ga, what you would notice if you turned off your Wi-Fi right now is that all of these documents are still there. And that's because what we're trying to do today is build a static website. Static just means not dynamic, meaning it doesn't change. It's not going to fetch web content from the abyss. It's just, you're just basically asking for that site. When you go to the URL, they give it to you and then you have it and you can click around. And you might have it organized so that when you click certain things, you have to call and ask for a new part of it. But generally, you pretty much just go there and then you have the website in your possession. And so that's really convenient because if you want to share your resume, you could just, give somebody whatever, if let's say your URL was nora.ga, and you went to give them your resume and your resume was at resume.nora.ga. Isn't that pretty clean? They can just, get that information. All you have to give them is that URL and they can get a document. It's like, you don't have to email somebody your resume. You could just give them web address and have it be available there. So that's kind of the thing that I think is cool and what I'm trying to allow you to be able to do. So the point of telling you about all of this, like sending you the website and why it's static versus dynamic, the reason that matters is because you've probably used websites like Google Docs, where you upload content and you write Google documents and then they're in the cloud and they're saved. And so in order to do that, there's lots of other like fancy coding stuff that has to go on. And you don't really need any of that. Like you probably don't need for your website where you're sharing, bio about yourself and your resume, maybe some papers you've written. Even if you want to write some content and put it up there, you don't really need anything to happen that's dynamic. And what I mean by that is, imagine a website that has a comments box like YouTube, and you enter a comment and then you send it out into the world and then everyone can see it. So have you ever thought about where that comment goes? Where does it get saved? What you're actually doing when you make a comment is you're signed in as your YouTube account, and you might notice that if you've ever tried to leave a comment without being signed in, you can't do that. And the reason is that they need to know who wrote this comment, where do I put this, because otherwise people could just write a bot to enter in the comment box a ton of data and they could overload their servers. So what's happening when you enter in that box is you're saying, I want to post this comment to this YouTube video, and then they're running a bunch of code that actually saves that on a computer somewhere. They save it on a hard drive and it really exists somewhere in the world, probably in multiple places, so that in case one copy gets lost, they still have it. And so, like I said, that's complicated stuff that has to go on when you need to save things, because, you know, imagine you have a website where you need to host comments. If your website has comments and that's open to the public internet, you know, anyone from any country, someone could be in Nigeria or China or Russia or, England, and they could put in a comment in your box, and they currently could like save onto wherever your website is. And so you can imagine why you might not want that. Like, what if your hard drive's only 120 gigabytes, and what if your computer was the computer hosting the website? Your computer would suddenly get full up with all these comments and you'd run out of space. So for our purposes, we're going to do something much simpler, which is all we're going to have is just the content we want to publish. We can change that content and republish it, but once we've sent it out into the place we're going to put it, it's just kind of what it is. It's pretty small. People can go get it at the URL, but they're not generating content, and there's kind of no, risk in terms of that. And so if you've ever heard of full stack or front end or back end web development, that's kind of what I'm talking about right now. So back end would be the stuff like the comments that have to get saved, and front end is this experience where you just get delivered the code for the website and you get to just use it on your computer. And then full stack would be the combination of back and front end. So we're essentially just going to be doing front end dev, and we're not really going to be doing much coding, so don't worry. But there is definitely going to be some scary command line and some scary, black code editors and all that stuff. So if you go here, if you've done any preparation, you would have gone to the preparing your computer section and gone to either Windows or Mac, Unix, Linux. So for people online, could you speak up if you're following along right now?
I am.
Thumbs up.
Okay, Nagin, do you have, did you do any setup in preparation, or are you completely blank slate?
And feel free to type in the chat. Did not.
Did not. Okay, so do you have a Windows or a Mac computer? Mac. Okay, that's actually better because you probably won't have to restart your computer or anything. So for you, we're going to be talking to the people in the room who are doing this. But for you, if you go to the learn.hfes.uva.ga and you go to build a website, preparing your computer, Mac, Unix, Linux, you can click the link for Mac, and you can download the appropriate Docker for your computer. So if you're not sure whether your computer is Intel or Mac, you can go to the Apple symbol in the upper left, and then you can go to About My Computer, and you should see what kind of processor you have. If it says Intel anything, you have an Intel. If it says M1 or Apple Silicon or anything like that, you have an M1. So the setup for Mac is pretty simple. You're basically just going to download the appropriate version, run the DMG, the installer, follow the instructions, and then drag it into your applications folder. When you open it for the first time, it'll probably ask you if it can have privileged permission or something along those lines, and you definitely want to agree to that. You need that. For the Windows people, you have a little bit more of a complicated situation. So who in the room is using Windows? You. You. Okay. So I have videos on this. So if you end up not being able to do this today, you can go and do it after, but hopefully it's possible for you to do. So first thing we need to check is going to the task manager. And you need to go to Performance tab and look down right here where you see virtualization. It should either say enabled or disabled. Does it say disabled for anyone? Enabled? Enabled. Enabled? Enabled? Great, that's what we want. Okay, so this part can be a little interesting because, and you may have to restart your computer. It's good that the Windows people are in the room because you don't have to be on the Zoom. But the goal here, so from a high level, let's explain what we're trying to do. So the reason things are easy for Mac and Unix and Linux is that they all use a similar operating system. And if you don't know a lot about operating systems, that's okay. But basically at its core, a Mac is very similar to Linux, whereas Windows computers are just kind of different. And for development, people like to use Linux because it's open source and free, and it has kind of standard command set that people are used to using. And we're going to be working with the command prompt. So if you have a Windows computer, only on Windows 11 will you have the terminal app. It's called the Windows Terminal. It's basically a glorified PowerShell. But what Windows 10 or 7 users might be used to is just the command prompt. So it looks something like this. The problem with this on Windows is that it doesn't use the same commands as Linux, which is really confusing. So if you've ever followed a Ubuntu tutorial for anything, you've probably seen the command line. If not, that's okay. We're going to go through it. But this is even confusing for me. Like, I didn't learn this until I graduated from my computer science program, that like, why could I not type clear, which is the thing that you use in Linux to clear the command shell, just so you can get all the text away. Why can you not say clear in the Windows command prompt? It's because the command here is actually called CLS. I mean, how would you know that? So if you want to use Linux commands, pro tip, on Windows, you can use PowerShell, and they've actually aliased, meaning they just give it a command that translates to their weird version of whatever the command is called. And so you can actually use Linux commands in PowerShell. So if you type clear in PowerShell, it'll work. Clear. Now, it's not completely a Linux computer, so it can trip you up if you think it is. But you can do basic commands like ls, which stands for list. You can list the files in here, and I'm not sure if I did ls over here, it's not a recognized internal command. Okay, that's confusing. Same computer, two different command prompts. Why should they be different? It's kind of annoying. But another thing here is there's this thing that Microsoft made for Windows to make it better. So that you can actually use Linux like it's Linux, and it's called Windows Subsystem for Linux. Because under the hood, Windows actually does a lot of stuff that involves Linux. I think there's some Linux under the hood. I'm not sure all the details, but basically it's pretty easy for them to allow you to have a Linux virtual machine inside your computer. And for those who aren't familiar, a virtual machine is just like a fake computer inside your computer. So you could have lots of little fake computers inside your computer, but you only have your one real computer. I'm going to go to the PowerShell and start my WSL.exe. You don't have to follow along with this. I'm just trying to show you that that WSL is something that happens because I have it set up on this computer, hopefully. So if you need to set this up on your Windows computer, you're going to be following these steps. So if you scroll past the videos, which we'll walk you through it in video, you have to activate and set up Windows Subsystem for Linux. And so this is basically just an extra Windows feature that lets you have a little Linux computer inside of your Windows computer. And we want that because we all want to be able to use the same commands so that, you know, Lauren doesn't have to use different commands from everyone else. And in general, if you ever do any coding, you'll be glad you have a Linux computer on your computer. So you need to activate Windows Subsystem for Linux. And there's this thing that you may never have seen called Enabling Windows Features. So if you type in the search, Windows Features, turn Windows Features on or off. There's two important features you're going to want to have activated here. One is virtualization. So let's see, I think it's Hyper-V virtualization. I'm not sure if I have it here. But yeah, definitely you need Windows Subsystem for Linux. So for those of you who are doing this for the first time, that box was unchecked, right?
I'm just following on. I already have a website. I'm just
okay.
Yeah. Mine, well, I was kind of following the instructions a little bit too, and so I did like the WSL install thing,
Okay,
and
great.
now it's checked.
Okay, great. Lauren, so yours is checked now, or it was checked before?
We'll check now.
Okay. So click OK, and then you're going to need to do this WSL install if you haven't done this already. So you'll want to use PowerShell for this, just because it accepts both kinds of commands. So I don't really know what will happen here since I've already done this, but I'm going to go ahead and do it. Why not? So did that work for you, Lauren? WSL install?
I'll go this one. My computer first.
Oh, okay. So the reason that we're trying to use Linux is so that we can eventually use Docker, and we can use Linux commands to interact with Docker. So Docker is a little bit confusing, and you don't have to understand everything about it. But just a high-level overview is it allows us to run programs inside of it's kind of like a virtual machine, but it's a little bit different. So if this is your computer, and then, you might be able to have little smaller virtual computers on your computer. This is a thing you can do. We're not going to do this, but this is a thing you can do. And so, you could run some programs over here, programs over here, and programs over here, and they're isolated from each other. So stuff over here can't talk to stuff over here. Docker basically lets you run a really efficient version of a virtual machine that just does the stuff you want it to do. And the reason we're doing that is because we're going to use a couple tools to develop our website. These are tools that people use in industry to develop websites for commercial businesses. One of them is Node.js, which is a JavaScript runtime environment, which you probably won't understand if you have never coded, but that just basically means it's a place where we can that can run our JavaScript code so that the computer can understand it, because the computer understands zeros and ones. So it just lets us turn JavaScript code into zeros and ones. You might be like, well, I don't know JavaScript, so why would I want to be able to compile JavaScript code? And we're going to use another tool to let us do that, which is called Docusaurus. So this is a static website generator. What that means is it's going to use code to generate a standard website that you can modify, customize to your liking. But it does a lot of that basic stuff, similar to what something like Squarespace or Weebly would do, where it does a lot of the legwork for you and you just have to do the customization. It does that where it'll kind of give you, the navigation bar. It'll give you the functionality to be able to do stuff like have different tabs and have a blog section that has, reverse chronological blog posts. It'll give you the ability to, when you click on the thing up here, it brings you back to the home page. It'll give you the ability to have all this styling that has these, the text is colored green. And the best thing about it is it's going to allow you to write content in something called Markdown language. Now, Markdown is kind of like HTML, if you've ever seen HTML. If you haven't seen HTML, it pretty much looks like this. So you might have seen it if you've ever inspected the element, right-click inspect element on your browser, or I don't know, you may have seen it before, but it's just the code that builds up these documents. So google.com is actually HTML under the hood, and there's JavaScript code that runs inside your browser. Your browser actually runs JavaScript code, and it has lots of these weird little tags that create the stuff on the web page. It's just a fancy way to turn words into visuals, is kind of the best way to put it. And then there's also styling. So one of the things that this provides you is that there's something called CSS, which kind of goes hand in hand with JavaScript. And CSS is just code for styling your words. So your HTML is just, fancy words and things that you can do on a website. And then the CSS is the styling element that adds all the colors. So the reason that my Google is dark and that, you know, this is a rounded box instead of looking like Craigslist, which, by the way, Craigslist also has CSS. It's just much more basic. But if you've been to a website like this, you're like, oh, that's like that standard thing, like when Gmail loads weird or something. But that's basically just what HTML does when it doesn't have a bunch of CSS helping it look pretty. So the benefit of the tool we're going to use, which is called Docusaurus, it's made by Meta, who makes Facebook, and it's something that they developed to quickly make documentation sites for their code. But you can use it for all kinds of things. The benefit of it is it does all of this setup for you with the styling, and it's very easy to work with. And you don't really have to know how to code in order to develop the content. Kind of once you figure out how to work with it and deploy it, you don't actually have to know the code that's building all this website stuff. All you have to know is how to write Markdown. So you're like, well, I don't know how to write Markdown. But Markdown is really basic. It's even simpler than HTML. HTML is a way to write these web documents, like the one that you're seeing before you is a HTML document most likely. But it just lets us do really simple stuff to write something like this. So you want to make a heading. There's a special way to make a heading. You want to write text, you just type it. So if you look up like Markdown cheat sheet, this will give you the basic syntax for how to do things, but it's really, really simple. You want to do the biggest heading, it's a single £, a space, and then whatever your heading name is. If you want to do heading 2 and heading 3, so on, you just add more £, and those get smaller headings. You can bold things with surrounding them by asterisks. You can italicize with single asterisks. You can do numbered lists by just putting in the number, dot, space, and then whatever your list item is. You can do bullets, and it will turn these into round styled bullets later on. You can do bullets with a dash, a space, and then the item. You can even do code blocks. You can do lines. You can do links, and you can do images. So if you think about like a web document and the kinds of things you might want to put in it, that covers like 90% of it. And there are other cool things you can do with it beyond that we don't have to get into too much. But Facebook has really good documentations on extending the Docusaurus website, which I also have it linked on resources later on, customizing your website. But they have all these guides on how to extend your Docusaurus website to your liking. So we're going to generate a website, and then we're just going to publish it, but later on you'll have the opportunity to customize it and republish it. And then you can have all of this nice templated stuff, but you can have all your custom looks. So I chose all the colors for this. I made it so that it defaults to the user's preference of dark mode or light mode, but they can also switch it if they prefer. I uploaded this logo. I changed this icon right here. It's called the favicon, so that it looks, it looks professional. It looks like it's something that is mine and not Facebook's. So getting back to WSL and doing that on Windows, if you restarted your computer and you're ready to go, if you go into PowerShell and you type WSL -L-V, so there's a space between the WSL and the -L and the -V, and you hit enter. This is what your goal is, to see something like this. Now you may not see this yet, so people in the room are using Windows. What do you see when you do that command?
Stuff.
Yeah, a bunch of stuff. That's expected. Lauren, do you see a bunch of stuff? Okay. Bunch of stuff is fine. So the place that we're going to go to fix this is the problem here is most likely that you have the old Windows subsystem for Linux kernel, which it doesn't matter what that is, but you just have to upgrade to the new one. So if you click this link, upgrade to a WSL2, you're going to have to follow these steps, which it's a lot of text, but basically copy this first command, you go into the PowerShell and go into PowerShell, and if you just right click, it'll paste it and hit enter. Oh, sorry. You'll need to go, when you open PowerShell, you need to open PowerShell and run it as an administrator. That's very important. Are you following?
Which command did you just say?
The all the way at the top, step 1.
Oh, so
Yeah. So I've already done this, but I think it will allow me to do this.
how do you paste and then PowerShell?
Just right click. You should just be able to right click if you have it in your clipboard. So go back to the thing and recopy it, and then if you go into PowerShell, just click and then right click, or it might be Control Shift V.
I'm gonna make sure it's on there. It seems like it's leaving my clipboard because I copied it.
Yeah, if you highlight it all first.
Then right click. Oh, it seems like it's leaving my clipboard for some reason.
Yeah. Is it in your clipboard?
I'll just can't type it.
Well, it's pretty long. If you highlight it all, like triple click it, right click, copy. Did you do that?
Okay. There we go.
That worked. Okay. Good. Lauren, how you doing? What's your problem?
This invalid line option. Install. This installing.
If you go to the website and activate, click on this app install WSL for Windows. And then, did you do it in an elevated command prompt as a, so PowerShell? Yeah, Windows. Is it instant administrator? Okay, do WSL, type WSL, space, dash L, space dash B. Okay, so I think you might already have the new kernel. I'm not positive of that, but try going to the Microsoft Store
And download.
and download. Actually, let me look something up for you because I want you to be able to follow. You need to learn how to Google if you're going to be doing this kind of stuff. Promise this is normal. So it's version 2. All right. Why don't you just in case, I don't think it'll hurt anything, follow the steps for upgrading to WSL2. So you want to make sure you opened an elevated command prompt, right? Like you did run it as administrator. I would just close it and do it again. Just when you search and you see PowerShell in here, yeah, that works. All right. So did you have an operation completed successfully?
Yes.
Okay, that's good. That's what we want. So then you want to check the requirements. This is important. So if you go to about your PC, Windows, you should see something like this. and we're looking for Windows specifications, and you want to see the edition and the version and the build that you have. If you have Windows 10, you guys have Windows 10, right? You want to make sure, do you have something higher than version 1903?
Oh, that's build. Oh, right.
Yeah, version 1903, build 18362.
Oh, yeah.
You're above that?
Yeah, version 21H2.
Okay, that's good. Lauren, are you the same? 21H2. Okay, so you should be good to move on. Now we're going to enable the virtual machine feature. So if you copy this command and paste it into your elevated command prompt with just click and then right click. Sometimes you have to do it twice. I don't know why. Copy, click, and then right click. Or sorry, don't click and then right click, just right click. That's the key. And are you getting an operation completed successfully?
Yep.
Yes and yes. Okay, great. I'm surprised this is going so well. Now this is a really important one. If you don't have the new kernel version, you need to download it. So this is like an installer. You just click on it and you download it, and then you run that program. And so let me know when you get through the installation for that. So, you're done? Okay, good. Mac people, I'm sorry that this is, you're having to deal with this, but are you going through the guide or doing other stuff, or you good?
I just installed it.
You got Docker? Okay, good. So then this is what we want to set WSL version 2 as your default version. So go ahead and copy that command and paste it. Again, you just want to copy it and do not click, just right click. And did we have an operation completed successfully? Wow, great. Lauren, how you done?
It doesn't say operation completed successfully, it just says for information on key differences with WSL2.
Okay, try it again. Just do up arrow and hit enter.
I mean, it's
Same message. I think that you're fine.
yeah.
If you have a problem, I'll restart your computer, but
Check it out.
Oh.
all right. The next step is we have to get, so you've essentially installed all of the bones for Linux, but you don't actually have an operating system. So if you've ever heard of Linux before, you may have heard of Ubuntu or CentOS or Kali or Debian, any of these. We're going to use Ubuntu because it's really commonly used, and it's what I use to do all this. So I'm using Ubuntu 2004 LTS. And if you click on that link that Microsoft gives you, I also think I have it linked here, Ubuntu 2004. And you can get it through your Microsoft App Store. So if you click that, you can open the store and download it. And just let me know when you guys have that.
I actually kind of done this already.
Okay, cool. So you're all good?
Yeah.
So now if you go here and you type Ubuntu, can you open the app?
Yeah.
Yeah? And you have a username and password and everything in there when you first opened it?
I don't think so. Well, I typed in some gibberish and then all this other stuff popped up.
Okay, so you're gonna be the root user. I don't think that'll be a problem.
What is Ubuntu?
Ubuntu is just it's like Windows but for Linux. It's a different operating system. So it's like Windows is an operating system, Mac OS is an operating system, Ubuntu is a Linux operating system. So Linux is just a kind of operating system. It's not really one operating system. If that makes sense.
Yes.
So Ubuntu is just the implementation that actually provides you the functionality to be able to use it. And we're going to be completely interacting with this virtual computer through the command line, which may be atypical for you, but that's how you can do a lot on the command line. So if you don't have it yet, you should download Visual Studio Code, which is an application for editing code. It is the best.
Do you use it for everything?
I pretty much use it for everything, yeah. Unless I need to use something specific for something else, I would use that.
I use RStudio. Okay. So what else do you use?
No. HTML and CSS.
Okay, so this is something you always do.
I'm still looking for this.
What about you, Nicholas? Do you always use Visual Studio, or like you're coding in Python? Do you also use Visual Studio?
I often use Google Colab for Python because it allows you to have notebooks like Jupyter notebooks, so you can run blocks of code one at a time.
Why do you use it instead of Jupyter notebooks?
Because I'm lazy and it's easy to get into.
Slider is also really cool for scientific Python. It's like Common RStudio.
Just kind of as the default. That was like the first thing that I ever opened, and I was like, well, I guess I'll just stick with this.
But you know, it feels like RStudio in Python. Also, I can test out an easy markdown. I use it for like home minutes. It's so free.
So, Lauren and remind me your name?
Daniel.
Daniel. How are you doing? Still downloading? Ubuntu. Okay.
And I just finished the installation of Visual Studio.
Okay. Of course, my install is having issues today. Just for this. Oh, there we go. Let's terminate it.
So what's the deal with being the root user on Ubuntu?
Usually when you start it up for the first time, it asks you to start a to create an account and give a username and then provide a password. I'm not sure if you skipped that when you first installed it.
I think I did.
There's a way to do it, but it involves commands that I don't have in front of me.
Is it like important to do eventually?
It's a kind of a security thing, so they can do anything. So you could accidentally delete all your files, for example, if you weren't careful. But you could do that as yourself as well. So
Self-destructive. Sitting there.
We just got a question about sending the recording after the meeting. And so I just posted that anyone who's not currently on the mailing list can send their email address in the chat or to our Gmail, and we'll send it later this afternoon.
okay. So I just was able to get into this. Lauren, where you at?
It is, I leave them to accept permission. So.
Okay. You're seeing debugging live, everybody. Because I'm trying to see if you can be not your root user. Again, I don't think it should be any problem. If you are in your WSL, and you type ls. Type cd dot dot or cd space dot dot and ls.
So,
cd user usr. No, just the usr, so users. Oh. And then ls. Just do cd and mention. Okay, so you're just gonna, I think, be the root user, and I think that should be fine. So just you can close out this window.
So does that mean that I like couldn't access files and stuff on my?
I think you should be able to because root can do anything. I'm just, everyone else is going to be a different user, so hopefully nothing will be majorly different for you.
I could like still cd into any directory on my computer.
Yeah, you can, but you're basically where you are right now. Change directory, cd brings you to a new directory. The place you start is the home directory for root, which is inside of your WSL. So it's like on a specific place in your real file system. It's hidden somewhere else. It's not actually your whole computer, but you can access your whole computer. But because of there's a speed, like a performance bottleneck, basically, for talking to files on your real computer. So the files that we're going to work with, we're going to have them inside the WSL so that we have really fast access. So if you have Visual Studio installed, you can open that up. Visual Studio Code, sorry. And if you don't have the remote extension that is mentioned here, which is WSL, remote WSL. My computer is struggling because I got a lot of stuff open. And okay. So if you're in here, you're going to see something a little different the first time. But if you look in this tab on the left, and Mac users, you don't need to do this. This is a Windows specific thing, but you guys will need Visual Studio Code as well. So if you haven't downloaded that and you're a Mac user, go ahead and download it. So you'll want to get type remote WSL, and it's this extension right here. Just click on it, and if you have an enable or install, just install it. This is just a tool that's going to let us use Visual Studio, which is made by Microsoft, to jump directly into our WSL installation. And so we can like pretend inside of the Visual Studio code editor, we're like inside of the Linux operating system. So everything's going to be Linuxy, and we can talk to the Mac people and use the same commands, and it's great. So Lauren, where are you at?
Okay, so I just installed the remote WSL. It gives me the option to explore mode or explore or open a window.
Yeah.
Mark it as done.
So once you guys have this done and your WSL is installed, your Ubuntu, have you opened it?
Yes.
And what happened when you opened it? Ask you to make a username and password. You did, and you made one. Yeah. Wonderful. You can close that. So this is the last thing I think that's going to be Windows specific. Oh wait, no, there is one more thing. So do you guys have Docker installed yet, Windows users?
No.
Okay, so if you go to the guide and you click on step 4, install Docker Desktop for Windows. It's just going to be another installer, and you download it onto your computer. And you want to pick the Windows Docker Desktop. Yep, and just install that. Lauren, you already have it? Go ahead and open it up.
Okay.
It's just a program on your computer. It should look something like this. Hopefully nothing it doesn't yell at you when you open it.
Yes.
Sometimes it does that. So you're all good? Has it started or is it starting?
No, it started.
Okay.
So then it's the distribution is enabled or integration is enabled with Ubuntu.
You check settings. And under the resources tab, you have WSL integration, you have the checked box, and you have the flip switch that says Ubuntu 24. All right, so you should be good to go. So you're still installing. There's going to be a way you can verify that that's actually true. So open a PowerShell window, just a regular one. It doesn't have to be elevated. PowerShell. And Mac users, you can join in. This particular step won't apply to you, but if you open your default terminal, if you just the Mac terminal, and you open that up, you should be able to type this command as well, assuming you're all set up right. Docker PS. And if you type that, do you see this? Wonderful. So Lauren, when you type Docker PS, do you see this? So now, if you open a Ubuntu window like this, just go in here, it's a program. Ubuntu. If you open a Ubuntu window, and you type Docker PS, do you see that? Wonderful. So you might be like, this is stupid. Why do we care that both our terminals agree? What's happening here is PowerShell is representing your real Windows computer that you have in front of you. And it's Docker Desktop is something you downloaded on your Windows computer. But we're actually going to be using Docker inside of our little fake Linux computer. So we want to make sure that we can use real Docker in our little fake Linux. And we want it to be the same copy that they're sharing. So what the steps we do in the settings to make WSL the quote backend of Docker basically means when we're inside our little Linux thing, that we can talk to Docker and do Docker stuff, and it happens on our real Windows computer, and that's important. So when the Mac users do this, they have essentially a Linux computer in front of them already. So when they go into their default terminal and they type Docker PS, which it stands for Docker processes, it just means tell me what Docker is up to, and that's an empty table that you see. So when Mac users do that, they're computing on, so they type Docker PS and they get this table. And so the reason that Windows users are checking to make sure these agree is we want to make sure that the Windows side and the Linux side are sharing the same copy of Docker. So you can close those terminals if you verified that. I know you're still catching up. And Lauren, you can go into Visual Studio Code. And if you type this or press this little green button down here, do you see that green button? At the bottom left, do you see a green button? Is there an option to do new WSL window using distro? So you click that, and you have the option Ubuntu 2004, and click that. So if all goes well, it should open remote, and then it should, at some point, successfully start the server, and it should be in. So you're in? Okay. Yeah, the first time it may take longer than normal. And Mac users, you can open up Visual Studio Code, and you are pretty much already in because you, again, you're using the default terminal on your computer. You're using the computer you have. So if you just go up to the Terminal tab, for you, this may be on the top bar of your computer, and you just go Terminal, New Terminal. You should get something that loads up, and you should have a little command prompt.
So my Docker PS thing is working now on both the Ubuntu and PowerShell. But then I missed the next step.
Did you do the Docker settings thing? I'll just skip the tutorial. Yeah, you're good. They go to settings, then go here. Just go to add resources. Voice or general. So you're using the backend, go to resources, go to WSL integration, and then you want to flip that switch and come on and start. All All right. So Lauren, how are you doing? You're in. So were you able to open terminal, new terminal? And now this applies to everyone, but we're going to need, we're going to start working with files and code. So we need a place to put the code that we're going to be working on the computer. So for Mac users, that's pretty simple. If you do file and then open folder, you can open a folder where you want to put your code. What I would recommend doing first is if you go into the Finder and you decide wherever you want to put your code, and just manually make a folder like HFES Workshop is what I would recommend calling it, just all one word, HFES Workshop, and just make a folder called that. And then you want to do file, open folder, and open to that folder, the actual folder itself, not the folder it's contained in, but the folder HFES Workshop. And so when you open here and you do that, for me, it looks a little different. This is something specific to WSL. But for Mac users, like, you should do file, open folder, and you get like the Finder window. Is that happening? And then you are able to pick the folder. And then is it just blank on the left? There's like a file explorer on the left with just no files in it. Okay, that's what you want. Windows users, you're going to do file, open folder, and the suggestion it should give you is like /home/username you chose. Are you with us?
Yeah, I think so. I open a new terminal and just the file open.
Okay, close it. Try file, open folder. Yeah, open folder. Do in that file explorer in the top bar. I've seen this before. I promise you're not on your own. Do the top bar, do // these are backslashes. It's above your enter key. / WSL $.
Oh, there it is.
Click Ubuntu, and then go to root. And this should be your, try this one, see select folder. This should be your folder. Yeah, I think this is your folder. Yeah. And Lauren, you were able to open the home folder? Like /home/ whatever it's suggested.
Yeah.
Okay, so now everybody should have a terminal and a file explorer up. Is that right? And are the people online all with us, or are we boring them?
See, we got a thumbs up. How
All right.
about you, Wasim? Are you okay?
All right, so now you're going to, if you've never worked with the terminal, if you have, this is going to be boring. If you haven't, hopefully this won't be too scary. So I'm going to tell you all the commands that you're using, and we might copy some, but the command line is just a place where you can run programs or jobs, and there's built-ins that you can call, like ls is something that you can call. Everybody can do this, Mac users, everyone can do this. Type ls, and ls stands for list, and this says, like right now, you're in a certain location in your terminal. Your terminal has something, type pwd, that stands for print working directory, and that'll just tell you where you are. So relative, for Windows people, relative to your WSL installation, you're in the /home/username folder. For you, you're in /root. You should say /root. And when you type ls, that says list everything that's in the current place that I'm at. So the current place you're at is home username, and the stuff I have in there is some stuff I was working on earlier, Zion and HFES Workshop test. And I'm going to do this over again with you guys, so you'll see it live. But what we can do here, and I'm going to pull up the guide here, because we all need a cheat sheet sometimes. And generating a website, and you can go pull this up too if you want to be ready to copy commands from here. If you go to first time, this no one should have to do. I've done this on both Windows and Mac. This only applies to Linux, and I don't think that applies to anyone in this workshop, but if it does, you can say in the chat. If you can, we already did this, making sure we were ready. We typed Docker PS and we saw an empty table. Now what we're doing is we're going to develop inside a Docker container. So while people were installing stuff, I've started to explain this. You might be like, why are we using Docker? I don't even care. What is Docker? Why would we use it? It lets you have those little tiny virtual machines that I was drawing in Paint. It's like a more efficient version of a virtual machine. And so it lets you run just the stuff you want to run on your actual computer. So we want to run like the ls command, and I want to run that inside my Ubuntu. But I wanted it to be able to like actually run on my physical computer that I have in front of me. And so what you can do the same thing in Docker. You can actually create new essentially virtual machines. I could create another Ubuntu Linux computer inside my Linux computer, and I could do that 10 times deep. Or I could make 10 Docker containers, is what they're called. And I'll explain what container is. But I could make 10 Docker containers that are all Ubuntu Linux installations. And when I jump in to each of those, I could be a different username and password. I could be a different person with different files and different programs. It's crazy. So the reason that we want to do this is because there's all kinds of, you need software to build software. And so there's this crazy hard thing that you have to do anytime you code, which is setting up your development environment. So that's sort of what we're doing here with downloading Docker. We're installing VS Code. We're getting ready to go. But a lot of times when you do this, like at companies I've worked at, people might spend a week, 2 weeks, 3 weeks setting up their development environment, doing no work, just getting computer stuff ready. So you're doing pretty good by being ready to go in like, an hour or an hour and 17 minutes. But the reason that we're using Docker is because otherwise, this was kind of a pain to install Docker, especially for the Windows people. But the alternative was we have to install everything that's going to be in our Docker container. So if you have Git and you don't have Git, and you have SSH and you don't have SSH, or you have Node but you don't, or you have Node version 17 and you have Node version 13, it's just going to be a headache for us to all use the same code and do the same thing. And people do this at real companies where they want to write code together, they want to collaborate on it, and they want to all be able to make changes that work the same way for everyone. So in order to do that, you need everything to be the same. And what you're going to learn today is actually something I don't know of a ton of people using this, Docker for this. But you can use Docker for this, and I think it's a really cool approach. I hope you like it. But basically, what we're going to do is instead of like Docker can be used for a lot of things. Like I said, you can make little Linux computers and do stuff on them. But a thing that this gets used for industry is that you might make a Docker container that just runs a very specific, they would call it a service. So maybe Amazon's payment button has a service that goes and calls and, bills your credit card. And so there's this very specific service that just does, one thing. It just takes in the details and it bills your credit card. And so something that you do, that's part of the back end. When you use the front end of Amazon, you click some buttons and you talk to the back end of Amazon. And so you might do a transaction and you might use the payment service for that. So Amazon could have the payment service inside a Docker container, meaning it's all in one, it's all on its, enclosed in itself. But if that was a computer instead of a container, they would have to have a different computer for every service. And Amazon literally has like hundreds, thousands of services. So you wouldn't want to have to, what if you only had one computer and you wanted to run the payment service and the user service and the shopping cart service and all this other stuff? You can have one computer and you can build containers for each little service, and then you can run them all on the same computer. And they get their own isolated workflows, and there's no dependencies, if you ever heard that word, where this thing needs, like I was saying, a different version of a software. It's a whole thing, but just trust me, Docker is cool, but we're not actually going to use it for what they use it for in industry. Mostly, some people use it for this, and I think they should. But basically what we're going to do is we're going to jump inside of a Docker container where we can then use a bunch of tools to build our software. And so the tools that we need, if you scroll down a little bit, I'm going to explain what all this stuff means. The tools that we need are Node, which is a JavaScript runtime environment. It's a program. You could actually install that on your Windows computer or your Mac. You could go to Node's website and you could download it and you could have it and you could run it out of your, CMD, your command prompt on Windows without any of this Docker stuff. And, Mac people could do that too. But maybe we get different versions and things are different. So we can get this from Docker, and Docker actually has like a container, which I'm going to explain, that has Node inside of it already. And so it has whatever particular version of Node is in this container that we're asking for. And then this already has a bunch of programs on it. Like it has SSH and it has all this stuff that's going to be standard between Lauren, between me, Daniel. Everyone's going to have the same stuff. And we're also going to install a few things on it. Like we're going to get Git, because we need Git, and that's it. So all the software that's in there is going to be standard for us. So then we kind of need to know what Docker is doing. So if you go into your command prompt and type clear, you can have a nice clear command prompt. And so if we do Docker PS, like I said, that's saying what is Docker up to? It's up to nothing because we haven't told it to do anything. Docker has something called containers. Let's see if I can explain this. This is extremely hard to understand, so don't feel bad if it's confusing. Basically, Docker has something called a container. Wait. And it has something called an image. And so a container or an image is what we're starting with. And so this is like the concept. This is like the concept of it. It's like the template for it. Like you're making a Word document and it's like the resume template that you start with. Then, so that's the image. And then from the Docker image, you can have lots of containers, which, like I said, are just, it's like a little virtual machine. It's like a little stripped down computer that just does very specific stuff that you want it to do. And so these little containers are all versions of this big image, but maybe this one is Lauren's resume and this is Nora's resume and this one's Logan's and this, another one's mine. And we can have lots of those. And so this is kind of the base concept, but then the individual instances of the containers can be doing different stuff. And so that's useful because, like, let's say you have like a web server, which is something that basically we're going to utilize to hold our code for our website so that when people go to our domain name, they get served our website. So a server is just a thing that does work. A server meaning it serves you. A computer server, like you might think of a server like, oh, there's a laptop, there's a desktop, and there's a server. It's basically like that, but it's more of a concept than anything. The idea is just basically I can go and ask the server for stuff and it can do stuff for me and give it back. So maybe you have a web server, an internet server that serves your website, and you have an image that does that because it's the same kind of thing that you want to do no matter where your website's getting served out of. And maybe you have a computer in Portland, Oregon, and you have one of the images on it running it. So people can go and get directed to that computer in Portland, Oregon, and this server container can handle that and give them their web content. Then maybe in Virginia, the DNS, the domain name service system or whatever it's called, directs you to these another computer in, let's say, Ashburn, Virginia. And so you get this computer, and that computer has two instances, so two containers of this image, meaning that, let's say Lauren and Nora call my server at the exact same time. So if you only had one container, Lauren goes and then Nora goes. But if we have two containers, they can do this at the same time. One person can talk to that container and one person can talk to that. So this is the basics of containers and images. You don't really have to know a lot, except that what we're doing, utilizes images and containers. And you're going to be like, why do we have to name so many different things? Why do we have to call the container and the image and the service? Why can't I just have one thing that's all of it? It's because even though we're essentially going to have one image and we're going to make one container out of that. And to do that, we're going to use another tool that's going to be a service that uses one image and one instance of that image, the container. So we're only going to have one of each of these. But actually, you could have a service with many images that do different things. And then you could have each of those images having many container instances that do different instances of the same thing. So I know that's a lot, but this is the reason we have to have what we're going to have is a service and then an image and then a container. And we're only going to have one of each because our goal here is to use we're just basically using this tool. It's going to save us some typing. That's the only reason we're using the service. Then we're going to have the image, and that's the template of what we're trying to jump into. And then we're going to have the container, which is the actual physical, zeros and ones that we're going to jump into and use. And then we're going to get inside of here, and we're going to work in the command line inside of that container. And that the reason that that's good, again, is because it saves us having to install all of that software, Git, Node, IP tools, or all these things that might be installed already in that. We can all just pull the same image, same strategy, the same thing that these containers are going to do. We all pull that from the same place. We're working with the same code. We make an instance of that image, which is a container. We jump inside of the container, and now we're in parallel universes that are all very similar. So you're in a parallel universe, you're in one, I'm in one, and we all basically can do the same stuff. And that's going to be really useful in a second. I promise it's about to get more fun. So,
Quick question, just to confirm that I got it right. The image is sort of like a class, and the container is sort of like an instance. Like an
yes,
object of that class.
that's a great way to understand it. Yeah. Yeah. And so if you can also do Docker images, and you should see, so I have some images downloaded, but you should see just a bar at the top and nothing below it. Is that right? So now I'm going to have, just for fun, so you can see that Docker does stuff. You can, you're going to do a Docker space run space hello dash world. And so, first of all, so hello world is a base image that exists. And you're like, well, I've never created that image, so how can that exist? It's a little complicated, but one of the ways you can get Docker images is by default, they get, if there's a name for them, if they exist and you're asking for them and you didn't make them up yourself, they get pulled from Docker Hub. And Docker Hub has this Hello World image, which is to help you determine whether your Docker installation works right. So basically, this is a stupid tool, but basically it's a super stripped down version of a Linux computer where all it does is it starts up and it prints Hello World to your screen and then it shuts down. That's it. It's very boring. But if you want to prove that you can do this, do Docker run Hello World, and you're not going to have it. It's going to be unable to find it locally. And so it's going to actually download it from the internet, from Docker Hub, and then it's going to run it. So we've got a pull complete, and it's all this text, and you're like, did it actually say hello world? But if you look there, hello from Docker. So did you guys were able to do this? So pretty boring, but that's a thing that you can do. And so now if you do Docker images, since you actually have that image saved now, you have Docker Hello World, and you can leave that there. It's 13 kilobytes. It's not hurting anyone. But if you want to get rid of it, you could do Docker RMI, which stands for remove image, and then hello dash world. Oh, and yeah, apparently we have to do dash force. Because some other image was referencing it. And now another thing you can do to clean up if you care, again, you don't have to do any of this, but you can do Docker system print and say yes. It'll just delete some intermediary gibberish stuff that was, making that work. And now your computer only holds on to the stuff that is important. So for me, Docker images will leave these images, the image and no development image, which are the kinds of things we're going to be making today that I've made for this workshop. So it's saving those so that in the future, when I run those images, it doesn't have to pull appropriate things from Docker Hub and rebuild everything. It kind of just uses a version of it already has, and it's a lot faster. Okay, now we're going to make our code folder, which I teased a while ago. So make sure ls, or pwd, print working directory, make sure you're in home username or for you /root. And then you're going to make a new directory, make a new folder. You could do this in your file explorer, but just you want to try to get comfortable doing things in the command line because it's just easier to stay in one place rather than opening up Finder and all that stuff. So to make a directory, you can do mkdir, mkdir, make directory, and then just give it a name. So I'm going to call it HFES workshop. And I suggest you do the same because I think there are references to that path elsewhere, but it's not a big deal. You can change it if you choose something else. And then do ls. So now you should see that option. Ls is list. Remember, this is just telling you what's in where I am at right now. So HFES workshop is in where I'm at right now. And it's a directory, which means I can change directory. I can cd into HFES workshop. And if you're wondering why that happens so fast and why you have to type the whole thing, it's called tab completion. If you type HFES workshop, if you just do H and you hit tab, it'll complete it. But actually since there's two alternatives with that option, actually if I wanted this second version, I would have to do dash and then tab to get text. But actually the one I want is that. So that's just a shortcut to save you typing. If it's a command that the terminal knows exists and you've started it, you can actually just save yourself the typing. So hit enter, and you should now see something like that you're inside HFES workshop.
So that is different from creating a source file.
Right, that's different. Yes, you can. Yeah, so this is where we want our source folder to be inside of. So this is the wrapper for that. So for you might have called the folder like HFES workshop earlier by making it in Finder. So you're already in that. So you don't have to do this step. But yeah. So everyone should be in HFES workshop. And if you type ls, there should be nothing in it. Nothing should print because you have nothing in there. I like to clear the window a lot, so I type clear. If you want to save yourself typing there, there's a cool thing you can do. If you type alias, and then C equals clear, and enter, and then type C. This is just, we've said when I say C, what I mean is clear. So now you can do C, and it clears. So completely optional, that's the thing you can do. And when you close this terminal, that will go away. So you can't do that next time. There's a way to make it happen every time, but we're not going to do that today. Now we're in the first time. And I'm just going to adjust this. Is everyone online doing okay? What you can tell?
Looks like it.
All right. So now we're going to make a source directory. You can do this two ways. It's pretty easy to make folders inside of here. I'm actually going to open up a new window just so you don't have to see all my files. Or open folder, sorry. /. Yeah, so now a lot of you would be here, and there are, again, two ways to make the source directory. You can either do mkdir./source or just source. The // So slash is just a separator between like parts of the path. The path means like, how do I get to the file? Slash, so if I said, you know, home slash njg4ne, that's my home directory, and then inside of that, I'm picking this folder. So dot is an alias for the current directory. So if I say dot, that just means it's a shortcut for exactly where I am right now. If I say dot dot, that's a shortcut for the folder directly above me. So we'll just use that syntax sometimes to save us some typing. But you can either do mkdir /source, or you can just do mkdir source. Or if you'd rather do it in here, you can just click the plus folder, type src, and hit enter. So now everyone should have a source folder. And then we're going to make a bunch of files that we're going to need to get into our Docker container and stand it up. And I'm going to explain what this stuff means. So let me get a terminal up. And now there are multiple ways to make a file as well. It's not mkdir, that would make a directory. What we want to make is a file now. The files we're going to make are Docker file, docker compose.yml or YAML, auth.sh, git file, and shorthand.sh. So you could do this in the terminal with touch. So you could say touch Docker file, and that just says, you know, start Docker file, but it doesn't actually put anything in it. And so now you should have it in your editor over there. The other way to do it is just to add a file like that, type Docker file, hit enter. So we can do that either way for all of the files. And the nice thing about doing it in the command line is you could do touch, and then you could type multiple files. So I could do compose.yml and space auth.sh, space git file, space shorthand.sh. And magically they all happen.
I mean, I had an issue.
Yeah. Oh, you're using PowerShell. You need to go here and open a new window with WSL.
Go away.
The little green thing. Open new window using distro. You go to. Yeah, and then you'll need to reopen that folder. Yeah, this is exactly why we're using WSL, so that you don't, because what was happening there is you're trying to use the touch program, which Windows doesn't use.
Oh, okay.
Yeah. Does everyone have all the files in the folder? You should have at this point a source folder, an auth.sh, a shorthand.sh, a git file, a docker file, and a docker compose.yml. And if you don't have all that, stop me. So we're going to put stuff in here, and you're welcome to copy and paste. However, I'm going to explain what's going on here because I don't want this to be a black box. The most frustrating thing for me is when somebody gives this amazing script that does everything for you, and it's complete gibberish, and you have no idea what it's doing. It's like, well, so I guess I just have to trust you that this works. And this might be gibberish to you because you've never written a YAML file before, maybe, but you can copy this if you want. You should be able to copy directly from the site, and you just either Control, or for Mac users, Command V to paste, or you can right click and paste. Are you all good?
I was just creating the folder or the files that you said.
So you can paste in, and we're going to go through these files one by one, but I'm actually going to start with the Docker file. So if you want to copy that one first, go ahead and copy and paste it in there. Make sure you save it. When it has this little dot up here, that means it's not saved. If you hit Control S or Command S, it'll save it. So what are we doing here? This is the standard format for a Docker file. There's reference material online for this. But basically, the way, because Docker images are just, it's a particular way to do stuff, right? So we're going to use a base image. We're not going to make this image completely from scratch. We're going to use a base image that we're going to pull from Docker Hub. So just like we pulled Hello World from Docker Hub, that was an image that we could use. There's actually a Docker image called Node that is made precisely for the purpose of being able to run JavaScript inside of a Docker container, which is what we want to do. So we're just going to use an official Docker image. It's, super safe. Lots of people use it. And we're going to use something called a tag of that, which is like a subversion, essentially. And we're going to use the slim version because it's smaller, and I've tested it and it works fine for what we're going to do. So why not have the smallest version? And so that's a tag that you can look for. It's somewhere in here. Slim. That's just what it's called. Right. Somewhere. It's somewhere here, I promise. So Slim is a version of the node image. So we're going to pull that from Docker Hub. So that's what this line says. And then we're going to run a command inside. So now this is something that's only going to happen when the container gets the image gets what's called built, meaning we're going to take a base image and we're going to do some stuff to it to get it ready to use. And then we can go and we can make lots of containers with it that all do the same thing. So this is only going to run once when we build the container, but we're going to run a program called APT, which is, it's a package manager. If you've ever used Homebrew on Mac, or like if you've done a sudo apt install for a Ubuntu tutorial before, that's what we're using is apt. We don't have to do sudo because when a container or an image is built, you automatically get to be the administrator. So you get super privilege until you say otherwise. So we're going to do an apt update -y. It's just the -y means we're going to say yes whenever they ask us a question, because they're going to be like, are you okay to install this? Yes, we're okay. And because we're not going to be able to interact with it, so we want it to be able to run behind the scenes. So we're going to run an apt update with the -y flag to say yes, and then we're going to run an apt install, and we're going to get the Git program, because by default, this image does not contain the Git program, and we'll need that later. Then we're going to switch to the user. There's a user in this node image that we pulled from Docker Hub that's already called node. So what's a user? If you type who am I, all one word. I thought that was a funny command when I first learned that. I'm NJG4NE. You're root. You are something HYZ. I don't know what your PID is. And you're something else, whatever your Mac user is called. So we're going to switch to the node user, which is a user that exists. It actually, if you say, SU means switch user, if I do SU node on my computer, user node does not exist because I don't have a node user. But the node image from Docker Hub does have a node user. So we're going to switch to that user. And we're going to create an environment variable. This is, you don't really have to understand this, but it's just pretty much we're creating a variable that we can then use elsewhere, so that we don't have to type this. This is pretty pointless. You could just as easily do work dir and then /home/node. What we're doing here is we just want to make it so that in the future, we're going to jump inside of this container. And when we jump in, we want to land at /home/node, but inside the computer. So if right now, if you went cd/node/home, it's going to be like, I don't know where that is. That doesn't exist because, again, it doesn't exist on your computer, but it does exist inside of the Docker image. So when you jump in there, hopefully you'll be right there where you want to be. And then, yeah, we're doing work dir, and we're referencing this variable home. And so that's work dir means working directory. That's where we're going to land when we get there. So that's all that's happening in the Docker file. So we're just building an image. We're extending the node slim image a little bit to work better for us. And that's what we're going to use. Then we're going to use docker propose.yaml. So this is optional, by the way. The reason we're doing this is because it's going to be less typing for you guys. You get to get the file all nice and ready, and then you just kind of hit go, and it happens. But because this is a Docker file, we could Docker build this Docker file, and then we could Docker run this image, and we could get a container, and we could Docker exec into the container. I'm going to explain that. And then we could be inside of it. But then just standing that up, meaning turning it on and like knocking it down, turning it off, it gets a little harder when you have to use the base Docker commands. So we're using this other tool that Docker has called Docker Compose. And that basically lets us specify in text how we're going to set this all up. And then we just hit go, we jump in, and we're in. And just trust me, this is much better, because otherwise you would have to type out these like 900 character commands, and it's very annoying. So right here, this is a different format. It's called dockercompose.yaml, which is the standard name. And we're going to pick version 3 of Docker Compose. That's just the version we've chosen to use. And then we're going to define services here. So like I was saying with Amazon, they could maybe have a file like this, and instead of just having one service like we have, they could have a services section, and then they could have like 6 different services in there. So when they hit go, they're going to get all of their services standing up and working together the way they want them to. And so that's the purpose of this, but we're using it just to stand up this single service. So if you see this, I called it dev-service. And again, there are dependencies that depend on that name, but that's an arbitrary name. You could have called that anything. You could have called that ABC123. You could have called it anything. Then the rest of these, so like version is a keyword. You have to use that word. Services is a keyword. Container name is a keyword. Build is a keyword. TTY, ports, image, and volumes. Those are all keywords. You have to use those words. But certain things we're naming. So we are naming dev service is what we're calling the service that we're going to be orchestrating these images and containers with. And then inside of that, we're going to give the container the specific instance that we're standing up. We're going to call it node development container, just so that we know what it is. If we see it, if we Docker PS, and we see it running, we know that's the thing that we put there. And then we're going to do build dot. That just means it says, when I ask Docker Compose to build my orchestration, it's going to need to build the container. Where does it do that? It's going to look in the dot folder, which is the current folder that the Docker file is in. So pwd, it's going to be here. It's going to look for that. Because Docker file and Docker compose.yaml are in the same folder. Docker compose.yaml saying dot, it's going to look in this folder that they're both in, and it's going to find Docker file, which is the default name that it's expecting to find. If you wanted to do a different one, you could define it, but the default name it is expecting is Docker file. And then we have to do this setting, TTY true. That just means terminal true. It's basically so that we can access a command prompt inside of the container, and that we can see it as if we were inside of it, because otherwise it would be blocked to us. Then we need to turn some ports on. So like I said, ports are just virtual poles that we can plug wires into. And the reason we need this is that because this is like a different computer from a conceptual standpoint, if we turn on anything, so what we're going to do is we're going to build a website and we're going to serve it while we're working on it. We're going to essentially, instead of like going to google.com and getting their website, we're going to make our website here. And just for now, we're going to hold it here and we're going to look at it here. And so we're just going to be like talking to ourselves pretty much. But the problem is, since we're doing this inside of a container, we want to be able to talk to it through our browser. We're going to want to be able to go to, it's called localhost. And localhost is essentially the IP address. It's a name that goes to the IP address of your computer with respect to itself. So when your computer wants to talk to itself, it goes to localhost. And you don't have any websites running at localhost. So if you go to localhost in your browser, it'll just spin because there's nothing happening there. But we want to talk to localhost for the purposes of developing. And so we're going to do that on port 80. You're good. We're going to do that on port 80, which is, remember from earlier, or you may remember, that 80 is the default HTTP port. And we don't really care about security right now because we're just talking to ourselves. But 3000 is the port that we're going to use inside the container to test the website. So the default place that it gets, the server exists inside of the container is on port 3000. So I can see this might be kind of confusing. So let's just do a quick visual. So you may have many layers right now. Let's just assume we're down to the layer of having. Let's just assume we're down to the layer of we have a Linux computer, right? So like for the Mac users, this is their Mac. For the Windows users, this is their WSL. And now you want to talk on, you have a port called 80, or even if you also have a port called 3000. But nothing's going to be happening here, right? Because we're developing inside of container. So this is our NDS, our node development service that we're building. And that service is just a way for us to plan a container. It's going to do all this work. So inside that container, we're going to we're going to build a Docusaurus site. And when we end up building that, you'll see this later, but that's going to be served on port 3000. Means Facebook is going to plug into port 3000, and that's where the website's going to be. So the problem is Facebook's doing that inside of here on this port 3000. And this also has a port 80, but they're not using that one. They don't care about this. So they're going to plug into 3000, but well, we can't access that on our computer's port 80. This is where our browser plugs into, right? We have our browser over here. We're going to plug into 80, but 80 is not plugged into anything. So we have to take 80 and plug it in to 3000. And so that's basically how we're going to see what's going on when our container is creating this website while we're working on it. So that's just so that when we work on it, let's say I want to change, I changed the heading. It was called heading 1, and I want to change it to be called, an actual heading, like introduction. So I type introduction, I want to save it, and I want to see the change. I have to be able to look at that in my browser. So that's how that happens. I hope that's clear. Now we have to use an image, and this is just essentially giving a name to this image that we're building. So when we built from the Docker file, which was at the dot file location, the current directory, we're building an image. We're going to call that image node development image. And then we're going to have a service that turns on a version of this image with this container name. It's very meta, I know. The last piece of this is we need volumes. A volume is it's kind of like the port concept, but it's with files. So right now, like I said, how this NDS, this node development service, it's completely distinct from our computer, right? Like it has all of its own stuff. So the reason that I don't have a node user, but it does, that kind of thing, the reason it has a home node folder, but I don't, it's because it's its own computer. So when I want to have files on my computer, you want to be able to like edit those, right? You want to be able to maybe email those to someone or upload them to GitHub or whatever, move them around. Most of all, you want to be able to see them in VS Code. So we're going to have a source folder. This is where our code for our website is going to go. SRC is short. It's a commonly used thing in industry for like source, SOURCE. And source code is just the initial code that you write. Then it gets turned into zeros and ones, and then the computer runs it. So source code is what we're writing, like a JavaScript file, a Python file. And the purpose of these volumes is so that we can, essentially like we did with the ports, if we have our little folder here, and we want to be able to see, we want it to live over here on the, in this case, either WSL or Mac. We want it to be able to live on our WSL or our Mac so that when we turn this container off, all of its files don't just disappear, because otherwise that's what it basically happens. Is when we turn this container off, it just poof, it goes away. So we want these files to persist. We want them to stick around. So what we're going to do is we're going to make a little tunnel here. We're going to map these files into something over here, and we can call it anything. This could be called A, and this could be called B inside of here. But when we're in here and we ask for B, we're going to get A. Does that make sense? So the purpose of the volumes, again, is to map from your actual computer to your little fake Docker computer. So in our folder where we are right now, which is dot, we have a ./source folder. We have a ./git file. We have a ./auth.sh, and we have a ./secrets folder. Oh, we don't have that yet. So go ahead and create a secrets folder. Oh, not inside source. Not inside source.
You're creating the package files that are stored on your computer, so the ones that are on the virtual.
Exactly. So you have a secrets folder, you have a source folder, you have git file, and an auth. We can exclude shorthand because we're not actually going to use that inside the container. We're going to use that outside, and I'll get to that. And then there's a colon, which means, you know, the left side of the colon is our side, and then colon, the container side. And so when on the container side, we want to map the source folder to be at /home/node source. And the reason we're doing that is because when we built our image, we wanted to land in home node, which is where basically node's home folder, where it's supposed to keep all of its files. So we've mapped source to be in home node source so that when we land in home there, we have a source folder. We're also going to do that with the git file and the auth and the secrets, except we're putting these in different places. So auth, you can really put anywhere. You could call it, you know, it's auth.sh over here. You could call it ABC123 over here if you want. I'm just going to call it auth with no.sh, but it really doesn't matter. And I'm going to have it in home node.
So when I create a secret folder, those folders if I use the French company.
Oh, that's because are you in the source folder right now? If you do pwd?
No.
If you click on source, you see them. Oh yeah, you made a secrets file. You want to make a secrets folder. Yeah, and that's actually not under source. That's on the same state as source. Does everyone need a break? Should we just like stop for a bathroom break, water?
Yeah, I'm just going to the restroom.
Yeah, it's been a while, so
Let's take a 5 minute.
all right. Online people, we're taking a quick break.
Have you given this workshop before?
No.
So you just built like this website and pulled all these resources together for this?
Yes.
Wow. This is incredible.
Glad you're enjoying it.
And that it's working. I don't know. Like,
Yeah,
I mean,
so
you've been doing a
far.
little bit of debugging, but it's been like extremely smooth for being in command lines and like having 6 different softwares that we have installed.
Yeah, I appreciate like the immediate one-on-one troubleshooting also.
Yeah, that's why I thought it'd be better to have people in the room because we could just do that.
Yeah, and I like your 3D paint. I like you downloaded that. I so am.
I wanted to have the tablet so I could write on here, but I couldn't set up. So
Like you're doing great. I mean, your drawings they make sense. So
Yeah,
That's
I'm
good.
impressed for you like with your mouse drawing skills.
yeah, it's pretty good.
it's pretty stressful when you're writing 1,000 with the mouse and you're like, is this worth it? You guys,
Yeah.
do you know what I'm trying to do?
Right.
So real quick, so the source folder is
Oh, awesome. Okay, we're gonna is everybody ready to get started again?
yes.
So I'm gonna jump back into VS Code where we left off. And we are just, I was just explaining how the volumes are mapped to from your computer into the container. And so the last 2 pieces of this are, we have to make sure that this is a very important name. This one is not arbitrary, and neither is this. So this .git-config, I'll explain what that means later when we use Git. But basically, there's something called a global configuration file for the Git program, and Git is how you do source control, basically put your code up into the cloud, and we're going to talk about that because we're using GitHub to publish our website. But the global configuration, meaning just like the settings we have for our Git program, are stored in this file called .gitconfig. And dot is one of the most confusing things in the Linux command line because it means all kinds of different things. In this case, it means our current folder. In this case, when it's in front of a file name or in front of a folder name, it's like a hidden folder or a hidden file, which is really confusing because if I call something, like I'm actually in, if I'm here, ls-l, or ls-a, sorry. If you do ls-a, which stands for all, it'll actually give you even the hidden files, which includes dot, the current folder, dot, the folder above us. But in this case, we had a folder. If we had a file called, instead of calling it a Git file, we called it .git file, it would actually be hidden from us. So we would have to do ls-a in order to see it. And that's it's just a convention because sometimes you want to hide files and not use them for certain things. So that is a specific thing where when Git inside of our container, looks for a configuration file, it's going to go to exactly the current user's home folder, which is home node, and then it's going to look at .gitconfig. So it has to be exactly that path or it's not going to work. The other thing that has to be exactly like this is the .ssh. So this is actually .gitconfig is a file, .ssh is a folder, which is a standard place that you put key files. We're going to talk about key files, which are a way to authenticate. Instead of using a username and password, we're going to use these key files because we're going to talk to GitHub over SSH, which stands for Secure Shell. Don't expect you to know all the intricacies of SSH, but basically SSH is a way that you can talk to computers over the internet. So just as a quick demo, I have I should have a network. I use this program to create private networks for all my computers, no matter where they are, which if you want to talk to me after about, we can talk about it. But I have a computer on my network called Pi. It's a Raspberry Pi. It's upstairs. And I'm pinging it, which means I'm just like checking to make sure it can respond to me. And I can actually SSH on a port to user at that computer, and I have a network where Pi resolves to an IP address that's 10.65.20.2. It's kind of like a domain, the same way Google.com can resolve, meaning get translated into an IP address. I can have that same thing set up on my computer so that when I say Pi, it automatically talks about this IP address on my little network I made, which you're not going to do. But basically, I could do that, and then it would allow me to log in. So it's going to ask me for password, which I'm not going to type in. But that's actually talking to my computer, and it would let me log in. And it establishes a session where we can communicate over the internet in a little encrypted tunnel where I can talk to it can talk to me, and nobody else can watch. And so we're going to use that tool, SSH, to talk to GitHub. And that's going to allow us to not have to type usernames and passwords, which is useful. So in Git file, which should be empty at this point, you're going to want to open that up, and you're going to copy this base in here into there, but you're going to have to change some stuff. So if you already have a GitHub account, you should know that. If you don't have a GitHub account, that's okay. You can make one today. You should, at the very least, have an email account that you can access right here today, right now. But if you have a GitHub account, figure out what email you signed up for it with. That's what's going to go here. So if you signed up for it with your email at provider.com, that's what you put there. And then in the name, you can put whatever you want here, but I like to put something in this that indicates that I'm inside of a Docker container. So like maybe I'd be, Docker learn. And that would just, the reason that we're going to do that I'm just going to say Docker dev Windows 11. The reason I'm going to do this is because this user, this named person who's going to be talking to GitHub over the internet, is going to be establishing an identity, and they're going to be proving that they belong in GitHub and that they're allowed to put stuff there and deploy stuff there. And so you want to know, you would want to be able to know when you're doing this inside of a container, who did that? Oh, I did that. You know, you could make a different one of these for your, maybe you have a Windows computer, but you also have a Mac, and you say, oh, well, I did this on my Mac, so I would call this like, you know, Nicholas Mac, or I did it on a Mac inside of a Docker container, so it was Nicholas Docker Mac. And that would just say, it's just a way for you to know when you see it on GitHub, you'll see the changes. You'll see that, you know, Docker dev made a change at this date time. And you would know based on this name you're setting here that that's, you know, who did that. And this is just standard format, the user brackets, and then the name, email. You have to use those exact words, but everything after, you don't have to use those words. You can use, you have to use your email, and then you can use any text string here.
I have a question.
Yeah.
Should I replace the whole name with my GitHub login email address?
Yes. So if you used, you know, njg@virginia.edu for your GitHub, you would put that instead of completely replace your email at provider.com. So hopefully that's clear. And again, the reason we're doing that, we're setting that so that this gets magically linked up to the .git config file inside of the container, so that when we're in there, we can talk to GitHub with this identity.
Should the GitHub username be inside the brackets?
No, it should just say user, the word user. Yeah. And your GitHub username shouldn't be anywhere in here. It should only be the email that you use.
Okay.
So like it wouldn't be username at github.com. It would be like, you know, abc@gmail.com. All right, everybody good on that? Okay, so the next piece of this is we're going to make this little shorthand file. And I'm going to explain what this is. This is technically completely optional, but if you want to use all the commands that I'm using later on, you'll want to have these set up. And so you're going to want to paste this in here. And I'm just, you know, a computer nerd who knows how to do this, so I did that for you. You could have done this yourself. Basically, I'm using the alias thing, the thing we did to make C equals clear. I'm just using that to make a shorter version of all of these slightly longer commands that are going to use Docker Compose, which is a thing I can use. It's a tool I have. And see, it's telling me it's version 2.5.0. So Docker Compose is a program I have. When I installed Docker, I got that. You guys all have that too. And so I'm going to alias some commands so that when I want to say Docker Compose up-d, I can say DC up. It's just a shorthand. Same thing here is that this is a fancy way of making a shorter command so that instead of saying Docker Compose exec dev service bash, I can just say DC in dev. And again, you really don't have to understand why I'm doing that. If you want to use the full command, you can use it and I'll show it. But this is this will allow you to have a shorthand once we set it up. So just paste that in there and just trust me. You'll also want to have the, where's auth.sh? Oh, right here. The auth.sh, paste that into the auth folder. So like I said, shorthand is something that we're going to use to have shorthand on our actual computer. That's why we didn't put it in the Docker Compose volumes. We didn't actually put it into the container because our goal for that is to use it so that we can use Docker Compose, which is the thing that we're making the container with. So we don't actually need it inside of the container because we're using it outside. Whereas auth.sh we put as auth inside the container. So we need to have it in the volumes. So what's going on here eval, you don't really need to know what this means. Basically, there's an SSH agent. It just means a thing that will prepare to talk to GitHub. And we're going to make sure that's running. So the eval thing just says, make sure the SSH agent is running and ready to talk to GitHub. And then we're going to SSH add an argument that we're going to give when we call the shell script. Again, you don't have to understand that syntax. And then we're going to test the connection, make sure everything's working right. And so this is something we'll do once we're inside the container. And if everything is set up right, we should get some output that says, yeah, you're good to go. You know, GitHub's ready to talk to you. And again, well, I didn't explain this yet, but .sh shell script, it just means, you know, commands I'm writing with CD. CD is a command. I could put that in a shell script, and then I could run the shell script, and it's just like I typed it myself. So that allows you to write a bunch of commands that you want to write one after the other, write them all up, and then just kind of hit go. And they happen. There's a little trick we have to do to make sure we can actually run it. And so that, does everyone have shorthand.sh and auth.sh made and pasted? Good to go. Saved. Okay. So now if you do ls and make sure you're in that HFES workshop folder. So if you do ls, you should see all those files we made, the 2 folders and the files, right? So what we're going to do is right now we do ls-l. ls-l means list and then use the long format. So tell me a lot more information about the files. If we're looking at our auth.sh and our shorthand.sh, we call them shell scripts, but we really just made them like files. And there's this whole thing of file permissions and what you can and can't do. But basically, the 3 things you can do with files: you can read them, you can write to them, or you can execute them. And folders, by default, they use the term execute to mean go inside of. So if you want to go inside of a folder, it has to be executable. And if you want to read a file, meaning like click on it, see what's in it, you need to be able to have read access. If you want to write to a file, meaning edit it and save it, then you need to have write access. So the highest level is read, write, and execute. So what we're going to do is give ourselves read, write, and execute privilege on the shell script files so that we can actually run them like their code. So the way we're going to do that is with this command, chmod 700./star.sh. I'm going to explain that. So ran that, and then we do ls-l. Did everybody get that command pasted? It didn't work? What happened?
Yeah, it was not recognized as the name.
You are not in, you're in PowerShell for some reason now. We left your, so just go to the green thing, or actually terminal. Terminal, new terminal. And then in the drop down. Yeah. Go to. And then you can delete those PowerShell instances.
We have another question from Naveen.
Yeah.
How do you go to the HFES workshop directory on the desktop?
So if you have a Mac, did you put the HFES folder in the desktop? Yes. So if you do CD right now, you should see lots of folders like desktop, documents, lots of stuff. If you do CD and then space and then capital D desktop / and then HFES workshop, assuming that's what you called it, and that should take you into that folder. Let me know if that doesn't work. And Lauren, were you able to do change mod?
This is operation document.
Did you have that problem?
No, it was on.
Use the green button at the bottom and just open a new window using distro. And close this. Save it, save it. New terminal, turn on your terminal. And then Oh, you put it on your desktop? Yes, no, sorry. You should have created this in, I think you can copy it there. So you should have done file, new folder, open folder. Oh, you'll have to do this. Just open the top bar, // WSL, $. Go to Ubuntu, and go to home, ML folder, and then select this folder. Yeah, and then you're going to want to move the files. Actually, create a new folder, an HFES workshop. And you won't have to make all this stuff again. We can move it. And just do file, open folder again. And then L board and HFES workshop, select folder. Now, if you go open up a file explorer window, go to your desktop and find that folder and click on it, double click on it, and select all. And then Control C, or just drag it over. You should be able to drag it over. And just copy. Oh. Yeah, this is try Control Z. Undo. Try file, open folder, and yeah, delete that folder and make it again, and then try dragging this stuff again. If you, yeah, let me go to it. Okay. Just let me know when you're back at a point where I can help you, because that's a fixable problem. All hope is not lost. So everybody else was able to change mod the files. So what that command did, chmod stands for change mode. It just means change the permissions of this file to be whatever. And then 700 is a special code that means 7, which is the highest level of privilege for me, 0 for everyone else, 0 for my group, people in my group, and 0 for everyone else. And 7 means everything. It means read, write, execute. It's just a special code. And then we're saying // meaning current folder / and then star, which is a wild card. It means fill in the blank, anything, .sh. So currently we have 2 things that match that formula of anything .sh. So it's just going to change mod 700 for all things in our current folder that match star.sh. In that case is auth.sh and shorthand.sh. So now if you do ls-l, you should see, it should change color probably, and you should see RWX and then a bunch of dashes. Lauren, how you doing? Having water? Okay, and then still going. Do you mind if I type? And you're not in this. Okay, that's right. That's an important step, opening remote. You want to be inside of it. Yeah, and then when you get that thing to pop up, you invite you there, you go there. Yes, I trust the authors. That's probably the step that is missing. Yeah, that looks like all looks like yours now. Did you copy the files to here?
Yeah, I can mention it.
I'm not sure. I know what the problem is. It's basically saying those are the administrator's files. They're not yours. Just if that fails, yeah, as yourself inside of this remote. That's why we tried to get into the remote window, because that gives us all the privileges we need. Sorry, guys. So you should have 2 executables now. Everybody was able to do ls-l and get the green.
I don't have the colors.
It's probably fine. Do you see the RWX and then a bunch of dashes next to the script files? Okay, then you're good to go. So you can clear the window or see. Ooh. Yeah, I don't have. Oh, okay. Yeah, clear the window, and then you're in this folder, and you have 2 executables now. So what we're going to do is we're going to run this script, but we actually want it. We want to run it in our current session, and it's not important that you understand what that means. But we could run the script like this: /shorthand.sh, and just hit enter, and it would run. The problem is it would run that in a new session, and then all of those aliases would be in that new session, and then the new session gets destroyed, and we lose all that stuff. So we actually want to do this little trick called dot sourcing. So yet another meaning for the stupid dot. It's dot space and then dot slash shorthand.sh. Should be able to run this and get shorthands added. Did that print to your screen? And now if you go C and hit enter, assuming you didn't do that before, you now should be able to do that. Yep. And so that's good. That means what you've done is you just added all these shortcuts to your current session. Now, if you were to trash this terminal and open a new one, you would have to rerun that script. But now that you've made it for the current session, you're good to go. At this point, you all should have a shorthand that you just used, a Git file that you filled out, a Docker file and a Docker compose.yaml that you wrote or copy and pasted. You have an authentication file that we haven't yet used. And you have an empty source folder and an empty secrets folder. Is everyone there? Okay. We finally get to the fun part of getting into the container, if you find that fun. So we're going to, I'm going to pull up the doc so you can follow along a little more clearly. So first of all, we're going to use Docker Compose to build our image, or it says container, but that's wrong. It's an image. So remember, we wrote a Docker file that took the node image and did stuff on top of it. So in order to use that, we need to build that image. And in Docker compose.yaml, we told it, build an image in the dot folder, look for the Docker file in the dot folder, then build that image, and then use that one for the container that we're going to stand up for the service. There's a service, and then we have an image we're using, and we're making a container instance. And in order to build that, since we haven't yet built that, Node exists out in the ether, but we haven't actually built it. So we're going to do Docker compose build to build it. So you can just type that out, Docker compose build, and hit enter, and some stuff should happen. If you see errors, let me know. Lauren, how you doing? Just making all the files again. Before you do all that effort, can you you're still not in a
Yeah.
yes. Oh.
But it's on.
Oh, you could do it in your file explorer. You go to file explorer and then hit WSL thing in the bar // forward slash WSL dollars and enter. Look through, go to home, and then everything, and then HFES workshop. You should be able to delete it from there. Control A and just delete it. Yep. And then I would make it over in the new window. And everybody's thing built? Did everyone have success in the building? So a bunch of gibberish happened that you don't care about, and now you hopefully have an image. If you do Docker images, this is optional. This is just to see what's happening. We have, looks like some node development image is what I called it, and that was created 45 seconds ago.
We have an error.
Oh. Try running it again. Try building it again. That's what I would say. Is there any more information for that error?
That's just rerunning it.
Okay. So everybody should have the image now, and if we do, so at this point we have a built image that we still have not turned on a container. We have not made a version of this. We just have the template ready to go. We haven't actually turned anything on. So now we're going to stand up the container using
Update.
I probably can't debug this over Zoom. I can maybe help you at the end. I don't know. Do you have any suggestions of what we should do here, Nora? I think I need to keep it moving because we only have like half an hour left.
Yeah, let's keep it moving, and if you're able to stay on for the end of the call, maybe if we have a few minutes, share her screen, you can help her.
Yeah, I would make sure you copied the Docker file correctly. And that everything is the same. My guess is it's something to do with not being from Node Slim or something like that, or yeah, I'm not really sure other than that.
I'll try Googling the errands.
Okay. It's a pretty generic error. That's why I don't know if you'll find much. So we have the image, and we need to stand up the container. We're going to do that with Docker compose up-d, which we aliased to DC up. So you should be able to take DC, capital U, and if you hit tab, you'll know you have it if it completes to DC up. Does everybody get us started? Yeah, you want to make sure you accept that. Yeah. Started? Good to go. Okay, so now if you do Docker PS, you should see node development image, node development container is running. You have the image node development image, and you have the container node development container, which remember we named over here. And you should see that running, and it was created 28 seconds ago. And the reason when you say PS processes that it's still in there, that it is running, is because we ran it, we turned it on in detached mode, meaning that it's behind the scenes. The -D flag, this is called a flag. It's -D, D stands for detached. So we said, turn on the container, but put it in the background, hide it from me. That's why we have our terminal back. Otherwise, we might have had our terminal hang up and wait for us to do something. But we said, go and run it and throw it into the background, and we'll jump into it when we're ready. So it's running right now, but it isn't like the Hello World that we ran earlier. When we ran Hello World, that was not something that was continuing to kind of sit there and spin. And that's because we didn't have this TTY, the TTY, which you don't have to understand exactly, but it just means we want to have a terminal, a command prompt ready to go inside of there. And we want to be able to access that. So you need to keep the container running for me. Whereas the Hello World, we just ran it, and then it ran to completion, and then it was done. And that's because it's trying to stay super simple and not bog down our PC. It's just trying to do exactly only what it was asked to do. So Hello World was only asked to print to the screen and then exit. This one is asked to stay around for us. So now that it's running, we need to get into it. And we're going to do that by running docker compose exec, which stands for execute. And we're going to call that on the dev service, which is what we called this whole service up here, dev-service. Hopefully you didn't change this name because the script file assumes that you called it dev or something -service. And then in the shorthand thing, we defined a shortcut for how to say this. So you could type this docker compose exec dev service bash, and bash is the shell program. So the thing you're currently interacting with when you call ls, cd, you're talking to bash. Bash is the program that's making all of this terminal stuff happen. So inside the node container, remember the container has all its own versions of everything. So it has its own version of bash. And so it knows where to find that. And if you just say, I want to execute the bash program, it's going to give you a terminal inside the container, which is what we're going for. So the alias that we created will allow you to replace this entire command with dcin space dev. So if you go in your command prompt and you do dc capital I and tab complete, and then type dev, this, you hit enter. Oops. I'm going to write it out. Did I do docker compose DC up? Oh, sorry. I'm not in the, I changed directories, so I'm not in the, yeah, so I should be able to do that. DC and dev, and look at that, I have a terminal. And you'll notice it says node at some gibberish. So I'm not actually at NJG4 at desktop anymore. I'm at node at gibberish. So now you're inside the container. So did everybody get inside the container? Lauren, have you caught up, or what is your problem? Is it still permission denied?
Yeah.
Okay, I would like to help you. Okay, so for those of you who successfully did this, if you type ls, you're now at a new terminal inside the container. And if you type ls, you are at your home directory. Remember, we decided we wanted to land in /home/node. We decided that in Dockerfile /home/node. And if you do pwd, print working directory, you actually see that you're in home node. So that's where we wanted to land, and you'll see that all those files that we connected are auth.sh, which we called auth over here, our source folder, which we called source. And you might be like, well, what about secrets and git file? Because we also put those? Well, those are hidden folders because they have the dot in front of them. So we can see them if we do ls-l, the long format. Sorry, not ls-l, ls-a, list with all, meaning even hidden files. So now we have .profile, .bashrc, all some system files we don't care about. And then we have our .ssh folder, and we have our .getconfig file. If we want to prove that we actually have access to these files, you can see that you have access because if you do cat.getconfig, cat is, I don't know what it stands for actually, but it just means print out the contents of the file for me. If you do cat, you should see the stuff that you typed in there. Did that work for everybody? Typing cat getconfig. And if you type .get and tab, it should complete it for you. So yeah, now we have, I proved to you that you actually have access to that. And now we are going to go on to use Node. And if you, don't do this because you're going to have to stop it, but I'm going to prove to you that we also have Node, which was one of the programs we needed because we pulled the Node Slim image, which has Node. We can actually do node -version. We have version 18.1 of Node. So we all should have, actually you guys can do that command if you want, node -version. We should all have 18.1 because we're all pulling from the same place up in the internet. Okay, now you are at home node and you're going to cd into src. So we're changing directories into src. If you ls, there should be nothing in there. All good? So now we are going to use npx, which is a node tool. And we're going to use this create.thesaurus thing that's up there in the node world. Basically, there's some stuff in Node where you can publish these tools. And Facebook published a tool that lets us create a .thesaurus app. We're going to use the latest version of it. This is going to call it my website. I would call it something else if I were you, but it will call it my website. And then we're just going to use the classic format. I'm going to copy this command and paste it. Then I'm going to arrow over. I'm going to change this to website. Yeah, and already hit enter, and it's going to take a little while. And you're going to have to say Y to say yes and hit enter if it asks you. I'm just going to install some stuff. Is everybody following?
What should we replace my website with? Like, how's that going to come up?
Whatever name that you would choose.
That's going to become the URL.
No. That's just going to be it's just the folder. It would be what you're going to call your Git repository, probably. Like if you would give a name to this group of code, what would you call it? You know? All right, so while that's doing its thing, pull up your email on your computer. I'm gonna pull up this burner email. And I have a video on how to do this, but it's pretty easy. Search Freenom DNS. This is the place where we're gonna get our domain name. And if you want to, search something. So in the docs, if you go to publishing and Freenom DNS, so this is build a website, publishing Freenom DNS. You're gonna see that there are these top level domains, .ga, .gq, .cf, .ml, and .tk, which are available to get for free for a year. You don't have to put in any payment info. You can just get them. and you just have to pick a name that isn't already taken. So for this particular user, I registered workshop.ga. Apparently that was available, but you guys can type in here and figure out a domain that's available, you know, something that you wouldn't mind sharing with people. You may need to think about what that domain is going to be, but you actually can publish today without picking a domain. So if you want to do that, that's an option. But I want to give you guys the option to do it here while you have me to ask questions about how to do it. But I do have a video on the resources page showing you how to set it up.
So you said it's, you get it for free for a year. What happens after the year? Do you have to like renew it?
Yeah, I'm not sure.
You have to snag it again?
The prices page says that renewals are also free. I haven't yet experienced what that's like, whether it's a hassle, whether you can actually get it for free. So there's that warning. But yeah, in theory, you can renew it for free as well. And so you'll just have to create an account here. You do have to provide some address. You don't have to provide your real address. You have to provide some name. You don't have to provide a phone number. So it'll ask for one, but you don't have to provide it. I chose to sign in with Google because it has a Google sign-in. And then you can essentially just check out for free without entering any payment info once you pick your domain. So are you guys going to do that now today, or are you going to do it later?
I'll just do it now.
Okay, that works. And Lauren, you can do that part if you're okay. It's kind of, I'm putting you on the spot a little bit too, picking a domain, because it's like, this might be my whole website.
I got an error when I ran that last week.
Yeah,
What? No, I just noticed it.
I know what's going on here. So because your WSL is running as root, you need to be root inside the container. So do you mind if I go for it? Okay, so pretty much here, Docker file, you have user node and this. Just going to change this to /root. And we're going to comment out this line. So we don't want to be the node user, we want to be the root user, because that's who is going to have permission inside of your thing. And we can fix it so that you wouldn't have to do this, but this is just the easiest quick fix, I think. And so everywhere right here where you see /home/node, replace that with /root. And then save it. You're going to have to rebuild. Well, just tell me when you get there, because you're going to have to do some stuff.
You really fixed her, yeah.
That's good.
So she's good to go.
I'm curious how you fixed it, because I'm glad, but I don't know what that error meant.
Yeah.
Okay, so I just updated those file paths. What was the next one?
Oh yeah, so do dcd.
.dcd.
No, the alias we created is go to shorthand. It's called dc down. Yeah, so type dc capital D and then tab. Did you restart your terminal?
I didn't. I mean, it had been working before.
Just try typing dc. City dot or space dot. ls. Oh, you're inside the container. Exit. Type exit to leave the container. Yeah. Exit again. It's not a root. Okay. No, you just open a new terminal. You're already in there. You're already there. In the right window. Just new terminal at the top. Drop down menu. Basically. Go to the bash. Click on bash. Change it to maybe plus, and then from the drop down, Oh, this is weird. Try opening a new window. New using distro. I have to open the folder again. Just wait, it's still opening. Yeah, okay. Did you get your domain picked? Checked out? Okay, good. If you want to get ahead, you can go to the Freenom DNS section and follow the guide, but I will get back to it. Okay, LS, right? Yeah, see, the HFES workshop, LS. We do /shorthand that I saved. And then do DCD down, DC down. Oh, dot space / shorthand that I saved. Dot sourcing. And then do it. Save it out. Make sure that works. Stop in there.
Computer science class.
And then do DC up space -- build. Push building and extending elements. And then do DC capital I and then dev. Yep, and now you're the root user inside of there. Just do LS. You should have all that stuff now mapped to the roots folder. So you should be able to follow along as if you're rooting. All right. Did you get your domain registered?
No.
Oh, okay. But you got one registered. Okay, so if you want to do this, hopefully you can get yours published today. So if you go to sign in, and you sign in however you did, you're going to go to the services dropdown and services, and then you should have a my domain section if you're signed in. And then if you go here to manage domain, do you see this button? It's below the filter button. And then you should have several tabs. Click on the one that says manage Freenom DNS. And you're going to have to add a bunch of records. So you have to add them one by one. If you Google GitHub DNS, click the first link, and then scroll down. You should see some IP addresses. Copy the first one, and then go back to Freenom. And in here, you're going to type your domain. So if your domain was workshop.ga, you would type that. And then in the target, you're going to paste that IP address. And it should be an A record. It should be automatically selected as type A. And then just hit save. Let me know when that works. So then you're going to do the same thing 3 more times, except you're going to replace the 108 with the 109 the first time, then a 110, then a 111. So it's the same IP address, it just counts up a little bit. Yeah, it'll be your domain as the name, and then the target will be each of those IP addresses from the GitHub DNS.
Would you mind running through that one more time?
Yeah, which part? So first of all, just Oh, did you pick a domain?
Yes, I did.
Yeah, go to services, my domains. Manage domain. Oh, sorry, I should have told you guys this. But when you checked out, you could have selected from the drop down. The default was 3 months.
Oh, I did.
Yeah, okay.
12 months.
You got 12 months?
Yeah.
Okay. Go to manage screen on DNS. And then you're going to put in there your domain, just the full domain. Yeah, and then in the target, you're going to have to Google GitHub DNS and find these addresses. First result, scroll down once you get there. Scroll down. These. And you're going to copy the first one and yeah, put it in the target and save that. You're going to repeat that for all those addresses. They're just the same address except it goes 108, 109, and 10, 11. Okay. Technically, best practice is also to create the IP version 6 records. I haven't tested that, so I'm not going to ask you to do that, but that is something, if you return here, except the only difference is instead of making a single A record, you would make a quadruple A record with these addresses. I know you don't know what any of that means probably, but essentially what we're doing here is we're just saying when you call our website, go to GitHub's domains, because we're going to set up our thing in GitHub so that when people get there, they see a version of our website. They actually see it. They get served that static website. So we're sending them, when they call our domain, we're sending them to GitHub, and then we're going to tell GitHub where it's going to find our website. And I have a subdomain registered for this person, which is called docs, and it's a CNAME record, which stands for canonical name. You don't have to do this step. The only reason you would want to do this is if you wanted to have docs.workshop.ga and you wanted that to be your URL, then you would create a CNAME record where you would just literally all you'd have to put here is docs, and then you would make it a CNAME record, and you make the target your GitHub username, which we haven't created a GitHub account if you don't have one yet, but your GitHub username.github.io. And that record is just another thing. It just says, hey, GitHub, people are going to ask for, workshop.ga, and then I'm going to want them to get to the docs subdomain. And you need to know that my account is the one where you're going to find a repo with that stuff set up. But just these 4 records should be sufficient. And the way that people are going to navigate to your website is just that domain, just whatever you picked, just the base Apex domain. If you don't have a GitHub domain, now would also be an okay time to do that. But if you check back in on your npx create Docusaurus thing, that should have completed by now. Did anyone not do that? Anything happening in the chat?
No.
Yeah, this is getting it's getting tiring.
So it's probably for the, like, is that my?
Do you want to have a subdomain?
Oh,
This is an optional step.
oh, okay.
Yeah.
I'll just not worry about it.
Yeah, I mean that, like if you wanted to have a special website just for your resume, for example, it would be resume.dc. So did everybody get the npx install and it worked? Okay, so now you actually have a website that has been generated, all the code for it has been generated. So if you look in your source folder on the left, all this stuff that you didn't make is now here. That's because Facebook made it for you. And that's cool because now you don't have to write it all yourself, and I don't have to tell you, create a static folder and it has all this stuff in it. So this is going to be a base site. And the goal for the end of this workshop today is that you will be able to publish this template version. So this will be like a vanilla template, and you'll be able to publish that. But you'll also, there's documentation where you can read about how to edit it further. And then in the future, you should be able to make changes and then publish those changes. So you should be able to publish this vanilla site within the next, hopefully like 15 minutes. And then in the future, you can edit it. But you're not actually going to customize it fully today, unless you want to. So it's currently, we've made the code for it, but we haven't built it. Just like we had to build our Docker container, we have to build our website code, because the code that we write to make the website is not the same as the code that our browser will actually run when people call and ask for it. So in order to build it, we would have to do a yarn build or an npm build. Yarn and npm. Yarn, that's what I'm saying. Yarn is the tool that you can use. It's just a node tool. It lets you do certain things in the node environment. npm is another tool that you can do things in the node environment. They're kind of alternatives, I think, where you can use one or the other. I tend to use Yarn because I've had better experiences. But right now, you have this, if you ls, you should have the doc site or whatever you called your website. And then you just want to cd into there. So for me, it's cd doc site. And then if you ls, you should see all that stuff that Facebook made. You should be in the folder that you generated. So inside source, we should have your website, should have a folder that was made for it. And then you want to cd into that folder. And then if you ls, you should see all those files. Good? Okay, so now, because we want to look at it before we publish it, we want to make sure it actually works before we publish it, we're going to build it and serve it and run it all on our computer. In other words, we're going to turn the code into code our browser can run. Then we're going to provide the code to ourselves. Then we're going to go in our browser and we're going to get that code from ourselves. Okay? And we can do this because we made that port connection, port 80 to 3000. That's what that was earlier. We were connecting the ports so that when we run, we're going to use Yarn to run this on port 3000. And then we're going to access it using the browser on port 80, and we're going to see the website if everything works. So in order to do that, we're going to do yarn start. We have to specify something, --host 0.0.0.0. And so Yarn is a node tool. It can do lots of things. One of the things it can do is run this start script. And this is something that, Meta has prepared for us so that we can just start it and see how it works. And then we're specifying host 0.0.0.0 because typically when you're in development mode, you only want something accessible on your computer. But since we're inside a container, it thinks our computer is the container. So we have to tell it, let the host that's connecting, meaning when we're in our browser, we are the host. We are also the server, but we're the host that's trying to connect, but we're also the host that's serving. Host just means computer, basically. So 0.0.0.0 means any IP address is valid, meaning just let anyone connect. If the port's open, just let anyone connect. And we need that because we want to make sure that even though we're connecting on our real computer, we want to be able to connect to what's inside the container. I know it's confusing, but just trust me. If you do that, you should see some stuff happen. You should do some building. And it'll say it's running, but it's not actually running yet. It's still building. And it's going to say that it's on localhost 3000, but that's actually where it is inside the container. But again, we mapped that to port 80. So we're going to access it at port 80. Oh no. What's the error? Do ls. Do yarn space install. Install. This is just going to try reinstalling the dependencies, all the packages that they're using. They try to install them, but they must have failed something. Hopefully it'll fix. I think I have that issue too. How's yours doing?
It says compiled successfully. I don't know if it's still personally installed.
Yeah, you can check if you go to your browser and you type in localhost. And hit enter. See a website?
That's automatically going to port 80.
Yep.
Which is unlimited.
Yep, because 80 is the default when you're in the browser. It's the default HTTP port, so this is the same as saying http://localhost:80. Same thing. And this has all those cool features, like all this styling. And click here, it has some documents already written for me. I can go browse. They're just stuff about how to make a DocuSource site. Pretty meta, you know, a website about how to make websites, which is what this is. And there's a blog section. Oh no, it's struggling. Yeah, so there's all this stuff, and like there's already a built-in switch where you can change to dark mode. And there's a bunch of default settings. If you click on like some of these links, they're linking to like Facebook stuff, like Facebook Q&As and Facebook websites and Facebook's GitHub. So this is all stuff you can change. And I have linked on the resources page after generating your website, I think at the bottom, all the way at the bottom, I think, oh yeah, extensive documentation. DocuSource has extensive documentation on how to edit these things. Some of it may be, you know, a little, you're gonna have to use some of these skills you learned today of using the command line, but it's explained in plain English. I mean, they'll explain, okay, if you want to make it do this, then change that. And if you can't particularly find what you're looking for, you can usually Google, how do I do XYZ in DocuSource? And you'll find a guide on how to do it. Or YouTube videos are a really good source too. I found a lot of good YouTube videos on customizing these sites. But now that we have a site that's harmless and we can publish, we're going to use that as our basis to publish. Is Nikki doing okay?
She dropped off, so I think she got it all set,
Oh, really?
as far as I can tell.
Okay. That's surprising.
Also, I have 30 minutes between 1 and 1:30, so we're going to go over it.
Oh, okay. Yeah, thanks.
Unless we can technical first.
Do you need to be done by then? Okay.
Yeah, after this, I'm going to go print some stuff.
Okay. So we all good?
I'm still waiting.
Okay. Did it build? Did the Yarn start thing work? Oh, it's still working. I think it just needs
I did. Is everything?
You got it?
I feel like
Good. So you're good. You're good. Lauren, we left you in the dust. I'm sorry.
No, it's fine. I caught up so that it was compiled successfully.
What? That's amazing.
Except I can't get a domain name.
Oh, why not?
It says everything is unavailable.
Oh, just try something else.
I did. I just like ordered like a bunch of stuff and nothing's working.
You have to, I've had this before, you have to type the actual full domain you want. So like type L4 down and out. Just try that. Just see if that works. Yeah, sorry, it's just a glitch. So try a couple other ones.
The hell ones.
Yeah.
Yeah.
Just try, if you want a different one, try a couple by trying it. Like
Okay.
full.
Cool. Thank you.
Yeah.
I had that glitch It was very annoying.
Now, I'll make a note of that.
What?
I'll make a note of that for myself.
Are you gonna do this later?
Mhm.
He doesn't. You just like the .ga because Cardella, like,
No, I just find it more pleasant than like GQ just sounds like fake. Like, yeah, like this is not the website ending. I think because like CA for Canada, it seems like more normal.
Georgia.
It's actually
Yeah.
for Georgia, the country. That's the reason for it. But
What is ML?
ML, it's also a country. It's like a small island or something.
Mhm.
But people will use it for their startups because it's like machine learning.
Yeah, I was gonna probably.
It's okay.
Yeah, I don't do it.
No judgment.
It's cool.
We don't have EEG stuff in there, but really machine learning at some point.
Oh, yeah, machine learning. 97, I was so proud.
That's awesome. That's not really fun.
It was really hard.
I'm just curious where it is. It's for Mali, the country Mali.
Oh, I'm thinking like MOLLY. Never mind. Yeah.
All right. So, who in the room has a GitHub account already? Is that everybody? Cool. So, when we made that Git file earlier, did you put the email that you actually use for your GitHub? That's good. So, go ahead and log into your GitHub on your browser. And see something like this when you land to the homepage. Is that right? So if you are on the web guide, oh, by the way, the website you're serving, now that we found out it works okay, you can stop it. If you just hit Control-C, and this is also Control for you as well, not Command. Control-C, it'll just stop the thing and get back to your terminal.
You said control, no command.
Not Command, yeah, Control. Did that work?
Yeah.
Yeah. I don't know why it's Command for a bunch of stuff and then it's Control for just that. Anyway, so if you're following along on the guide, we're on Publishing, and then we're on Build a Website, Publishing, Deployment. So we're gonna have to use Git. I'm gonna try to keep the Git activities to a minimum because Git is really confusing in my personal experience at the command line. But you're going to have your code in the Git repository. If are you all familiar with the Git repository? No? It's basically a place where you put code. It's kind of like a folder, like if you think a Google Drive folder, it's just like a place where you put your code for a particular project. So I'd make a repository for my website code and I'd put it there. If I had lots of websites or lots of apps, I would make different repos for all the different stuff. And repo is what you call it for short. So if you do the plus sign at the upper right, you can do new repository. And it's gonna be under your username. The owner is gonna be you. And then the repository name, you can give any name. I'm gonna give mine the same name as the folder that Facebook created for me. So inside the source folder, there's a docsite folder for me. But you could have called it anything else. So I'm just gonna make it called docsite. So just pick a name, description, you can put that if you want, optional. I'm gonna have this be public. I'm not afraid of anyone seeing this code. If you are, make it private, because currently anyone can go to your GitHub online and they can just view this project. They can see all the code. So if that's a problem for you, make it private. Qualification is that I haven't tested the private, so I don't know if there's any catches that happen when you do private. But if you end up having stuff in there that you consider private later and you want to privatize it, I think you can change that at a later date. Make sure add readme is unchecked. Do not check that. Make sure that add a git ignore says none, and it doesn't say anything. And then you can create a repository. And you should land to a page like this. If you land to a page that looks different from this, let me know. Are you good, Lauren?
I couldn't find where, sorry, I was checking out. But what file do you need to use?
Oh, whatever you, so,
Repository?
so you built the Docusaurus site, right? You use npx create.
Yeah.
And you have,
It's called .docusource inspired source.
oh, it's called my website.
Oh, okay.
Yeah, it's just they concatenate them together. It's
Okay.
called, so yours is called my dash website.
Gotcha.
There are multiple ways to authenticate with GitHub to make sure it knows who you are. And because think about it, even though this is a public repo, anyone has read access, meaning they can see it, but you don't want random people to be able to change your code, right? That would suck. So you're the only one who can write to your code right now, unless you give someone else permission. So you need to prove that you're you. So the cool kids are doing that with SSH these days, which you can tab over, click instead of HTTPS, click SSH, and it's going to give you this. And you'll need to copy that in a minute. You don't necessarily need it right this second, but you'll need that in a minute. And what we're gonna, so we created like the remote repository, meaning we have a place where our code can go live, but we haven't actually put it there. There's nothing there. So we made a folder that we put some code in on our actual computer, and now we want to like put that into the remote repository. The way that we're going to do that is with commands, and we don't need to do this one. So we're not going to follow this exactly, but we're going to follow it closely. And I actually have the correct commands on the resources page right here. So if you pass down to, yeah, let's create an SSH key first. So SSH is the way we're going to authenticate, and this is an alternative to a password, essentially. It's a whole thing how this works, but you have two keys, a private key, which is secret and it's yours. It's like a really big long password, but it's in a file. Then you have a public key, which is like a big long number, but it's in a file as well. You give GitHub the public one. You have the private one. You use a algorithm tool to run. Basically, some nonsense happens, and you and GitHub talk to each other. It has your public key. You have your private key. And so because you have your private key, you can prove you're you. That's what's important. Does that make sense? So we're going to generate keys, and one of the tools, one of these many tools that we need that's inside of our container, which you're inside right now, you should still see either root at or node at, a bunch of numbers. And one of the tools you have is SSH keygen, which generates these keys that we can then give one of them to GitHub. So you're going to type SSH-keygen, generate a key, and then a -t, meaning the type. And we're going to use this very nice modern algorithm that people use these days called ED25519. And then a space. We're going to do -C, which is a comment. And we're going to make the comment our email address that we use with GitHub. So in our case, it's going to be, let me check this. Yeah, okay, so in my case, it's going to be zionseg@gmail.com. This is the email address I use for that. And then I'm going to specify a file path, meaning a place where I want to put these keys. And we have a secrets folder that we have visible on our computer. We mapped the secrets folder to the .ssh folder. We did that earlier. That's a special reserved place where SSH keys are supposed to live. So if you click on secrets on the left, you have nothing in there right now, but we're about to put something in there. So in this rest of this command, you have dash lowercase f, and then a space, and then you're going to give a path to a key file that you want to create. So first of all, you have to specify the first part of the path, meaning how do I get to where I want to put it? So that's going to be squiggle, which stands, it's just a shorthand. The tilde is a shorthand for my home directory, which is home node. For you, it's root. If you want to be extra safe, just do /root and then whatever follows. So we're going to do squiggle /.ssh, and it should tab complete. If it doesn't tab complete, something's wrong. You following? Okay, and then you're gonna. This is the folder where you're gonna put the keys. This is mapped to secrets. Now you're gonna give your key a name. So you can give it anything, any name you want, but it's gonna be the name of the private key, which has no, like, it doesn't have a .key at the end. You have to go. So yeah. So does anyone else have to leave? I know we're kind of over time.
I have to leave.
Okay. You can do it.